Jakarta Enterprise Bean Architecture, Enterprise Java Beans Architecture. Here you can see Enterprise Java Beans architecture diagram with Oracle 8i. Jakarta Enterprise Beans EJB, formerly Enterprise Java Beans, is one of several Java APIs for modular construction of enterprise software. EJB is a server-side software component that encapsulates business logic of an application. An EJB web container provides a runtime environment for web-related software components, including computer security, Java Servlet Lifecycle Management, transaction processing, and other web services. The EJB specification is a subset of the Java EE specification. You can see here architecture diagram. EJBs are based conceptually on Java remote method invocation RMI model. For example, remote object access and parameter passing for EJBs follow the RMI specification. The EJB's specification does not prescribe that the transport mechanism has to be pure RMI. The Oracle, for example, Oracle 8i EJB server uses RMI over IIOP for its transport protocol, a practice that is becoming common among server vendors. Here you can see a EJB client interacts with EJB clients interacts with sessions. And EJBs are inside sessions. Sessions interacts with database files. Sessions and database files are in the inside in the server. The basic ways in which EJBs can be assembled, or the basic EJB architectures, can be described in terms of which kinds of beans or J2EE components are used, how client applications access them, and how the underlying domain objects are represented. The EJB architectures can be fundamentally divided into three categories: an entity bean architecture, a session bean architecture, and a session and entity tiered approach. Each basic architecture also has variations and refinement that can be decorated with a variety of J2EE components. The EJB specification does not dictate how enterprise entities are used, but it is clear from the evolution of the specification that certain architectures are assumed to be dominant. Some of the recommended architectures are explained in the J2EE blueprints. This document should be reviewed for more information about J2EE and EJB architectures. Here you can see a remote entities architecture. This illustration shows information flow through remote entities architecture. Information flows from the FAT client through the remote interfaces of the entities that reside on the server. The entities rely on the database for their values and attributes. If entities alone are used, then they must have remote interfaces that exposes all of the client servicing methods. In the absence of session beans, the client may only access the entity state through its remote interface and may not traverse relationships except as encapsulated by remote method calls. Only remote references and data may be returned by these calls. Finders may only return remote references as well. Client gain from this approach in that the distribution of the entities is transparent. Clients reference the entities as if they were local and do not need to worry about location. Entities can exist at different locations without client even being aware of it. The converse transparent distribution is that if clients are not aware of the distributed nature of the entities, then they may not be aware of the cost of invoking them. If the entities are fine-grained objects, that each fine-grained method invocation on them will end up being a remote call. The accumulation of this remote method invocation could sum up to a potential serious network communication latency cost. If container transactions are used for each entity operation, a separate transaction will end up being initiated for each method invocation. This could introduce excessive and unnecessary transaction management overhead if client demarcated user transactions are not used. Since entity beans are intended to be components, there are more restrictions placed on them than on regular Java objects. For example, thread spawning is disallowed. This may impose limits on how they can be used to model certain domain concepts. The limitations should be well understood and compared against the model to ensure that they are not discovered too late in the design phase. In general, however, this architecture is less desirable than other architecture types. The relationships limitations imposed by EJB specification are often an impediment to using this approach. Advantages: increase distribution, potential for greater location transparency. Disadvantages: not suitable for fine-grained entities. Communication overhead for each method call. Transactional cost of each method call. Client accesses many EJB interfaces, not single client interface or point of server entity. Much of the business logic must reside on the client. Here you can see a remote session beans architecture. This illustration shows the remote session beans architecture. The client application accesses the session remotely, and the session interacts with the Java objects on behalf of the client application. It is a common practice to apply a session bean layer in front of lightweight objects. This may take the form of the session facade pattern with lightweight entities or other types of persistent objects being managed. Since Session beans do not themselves represent durable objects. Often a session facade pattern will be used to converse directly with persistent data objects without the use of entities. Persistent data can be modeled using a regular top-link enabled persistent Java objects that are managed by the session beans and mapped using top-links tools. Since a few domain model objects actually live in the client's application rarely need to access the domain objects directly. But if regular objects are used, then they may be sent to the client if necessary, since no such restriction exists for them. Session beans are used to carry out most of the application logic. Stateful beans are used for those operations for which client identity is important, while stateless sessions beans can be used for single shot operations. All the EJB benefits of security, transaction, and distribution are available through the session beans. The exclusive use of session beans does not allow for overlay complex client behavior. All client behaviors is limited to services provided by the session beans. Simple client behavior is a general characteristic of all thin client architecture. Simplicity and fast thin client access are clear benefit of this approach. In addition, there is a great flexibility in how domain objects are designed and how these objects are mapped to the underlying relational database tables. Advantages: location transparency on session interface, fine-grained persistent object operations can be batched to combine into a single session bean call to communication to reduce communication overhead. High performance storage retrieval of persistent objects. EJB features available through single point of session bean entry to reduce container overhead. Can relate persistent objects, can pass persistent objects to the client side if necessary. Disadvantages: fine-grained client calls may require explosion of session interface calls. Persistent Java objects not included in EJB specification. Here you can see client is connected to session. You can see session and Java objects are inside the server, and session is connected to Java objects. Java objects are connected to database. Here you can see session facade architecture. This illustration shows the remote session beans architecture. Client application accesses the session remotely, and the session interacts with the Java objects on behalf of the client application. The majority of systems have relationships between application entities. This being the expected scenario, it is well observed and explained by J2E designers. More common, however, is to incorporate the domain logic into the session bean itself. This migrates the business logic from the client to the server, which provides a number of well-known benefits, including ease of maintenance, convenient upgradability, and increased access to server features. Regardless of whether the session bean simply forwards the operations entities or actually includes the application logic as a facade that fronts the local entities in its modular approach to remotely accessing server-side objects, it is also likely to be easier to maintain as J2EE specification moves forward. Since session beans tend to experience change to a lesser degree than other components such as entities, the decision to use stateful and or stateless session bean will likely depend on the amount of business logic incorporated into the session bean. Advantages: location transparency on session interface. Fine-grained entity operations can be batched or combined into a single session bean call to reduce communication and transaction overhead. Inter-entity method calls are passed by reference. Can maintain entity relationship. All components described by EJB specification. Flexibility to create new local transaction of specific method calls when required. Fine-grained client calls may require explosion of session interface calls. Some container overhead still incurred on each local entity call. Here you can see a client is connected to session. Session and entities are inside the server. Session is connected to entities. Entities interact. Entities are connected to database. Here you can see basic EJB component relationships. There are 4 major components that you must create to develop a complete EJB. The home interface, the remote interface, the implementation of the remote interface, the actual bean class, a deployment descriptor for each EJB. Home interface is an interface to an object that the container itself implements the home object. The home interface has create methods that specify how a bean is created. The home interface with the home object actually serves as a factory object for EJBs. The remote interface specifies the methods that you implement in the bean. These methods perform a business logic of the bean. Bean must also implement additional service methods that the EJB container calls at various times in the lifecycle of a bean. Client application itself does not access the bean directly. Rather, the container generates a server-side object known as the EJB object that serves as a server-side proxy for the bean. The EJB objects receive the message from the client, and thus the container can interpose its own processing before the messages are sent to the bean implementations. Why is this level of indirection necessary? Remember that the container provides services transparently for the bean. For example, if you deploy a bean with the transaction attributes that declares a bean that the bean must run its own transaction context, then the container can start up the transaction before the message is passed to the bean and can do a commit or rollback as required before return messages or data is sent back to the client. Here, this illustrates the interaction among these components here. The bean implementation contains Java code that implements the remote interface and the required container methods. The deployment descriptor is an object that specifies attribute of a bean. For example, the deployment descriptor declares the transaction properties of a bean. At the deployment time, the EJB deployer, together with the application deployer, can decide whether the container should manage transaction support or have the client to do it. The basic concepts. Before going into details about implementing EJBs, some basic concepts must be clarified. First of all, recall that a bean runs in the container. A container which is part of the EJB server provides a number of services to the bean. This includes transaction services, synchronization services, and security. To provide these services, bean container must be able to intercept calls to bean methods. For example, a client application calls a bean method that has a transaction attribute that requires the bean to create a new transaction context. The bean container must be able to interpose code to start a new transaction before the method call and to commit the transaction, if possible, when the method completes and before any values are returned to the client. For this reason and others, the client application does not call the remote bean methods directly. Instead, the client invokes the bean method through a two-step process mediated by ORB and by the container. First, the client actually calls a local proxy stub for the remote method. The stub marshals any parameter data and then calls the remote skeleton on the server. The skeleton marshals the data and upcalls the bean container. This step is required because the remote nature of the call. The note that this step is completely transparent both to the client, application developer, as well as the to the bean developer. It is a detail that you do not need to know about to write your application code either on the client or the server. Nevertheless, it is useful to know what is going on, especially when it comes to understanding what happened during a bean deployment. In the second step, the bean container gets the skeleton up call, then interposes whatever services are required by the context. This includes authentication of the client on the first method call, performing transaction management, and calling synchronization method in the bean itself, identity checks and switch. The container then delegates the method call to the bean. The bean method executes. When it returns, the thread of control returns to the bean container, which interposes whatever services are required by the context. For example, if the method is running in a transaction context, a bean container performs the commit operation if possible. Depending on the transaction attributes in the bean descriptor, then the bean container calls the skeleton, which marshals return data and returns to the client stub. These steps are completely invisible to the client side and server side application developers. One of the main advantages of the EJB development model is that it hides the complexity of transaction and identity management from developers. Here you can see the xbean x equal home.create method create. This is calling this is connected to home through create method, and home is connected to bean through EJB create method. Bean set access create method, and set xxx 42 higher and r3 equal get xxx method is interact with bean methods here through methods. These codes are inside the client, and so home and bean, and here for example Oracle API are inside the server. Here you can see enterprise beans. The enterprise beans are server-side J2E components and run on the J2E server in their EJB container, which manages their execution. Enterprise Java Beans component model. They handle the business logic of J2E application, such as a web application. They contains the business code, which is a logic that solves or meet the need of a particular business domain, such as banking, retail, or finance. The enterprise bean is a body of the code with fields and methods to implement modules of business logic. You can think of an enterprise bean as a building block that can be used alone or with other enterprise beans to execute business logic in the J2E server. An enterprise bean receives the data from client programs, processes it if necessary, and send it to the enterprise information system tier for storage. Retrieve data from the storage, process it if necessary, and send it back to the client program. In enterprise bean terminology, the installation process is called deployment. Here you can see JSP pages and servlets, and Java Beans components optional in web tier, web tier, business tier. The entity beans, session beans, message driven beans are in business tier. Database and legacy systems are in EIS tier. Web tier and business tier are in J2E server here. So JSP pages, servlets, and Java Beans components optional, and entity beans, session beans, and message driven beans are in J2E server. Here basically web browser, web pages, applets, and optional Java Bean component interacts with also interacts with JSP pages and servlets. JSP pages and servlets interacts with IES tier through Java Beans components optional, and entity beans, session beans, and message driven beans. Here application client and optional Java beans interacts with database and legacy systems in EIS tier through via Java beans components optional and entity beans, session beans, message driven beans. Here you can see EJBs and other application components. Here you can see JDBC, transaction manager JTA, entity EJB, JNDI, message driven EJB, JMS server, session EJB, web service and web services and servlets are inside WebLogic server. For example, here, Java client interacts with session EJB. Session EJB interacts with transaction manager JTA. Session EJB is connected to entity EJB, JNDI, and session EJB interacts with servlet here. Here HTTP client interacts with HTTP server. HTTP server interacts with servlet, and HTTP server is connected to web service here. Web service is connected to session EJB. Here HTTP server interacts with servlet. Servlet interacts with session EJB. Here SMTP client is connected to web service. Then web service is connected to session EJB. Here session EJB is connected to entity EJB and interacts with transaction manager JTA, and entity EJB interacts with transaction manager JTA, and connection pool. Connection pool, data source, and JTS enabled driver are inside JDBC, and connection pool interacts with data source interacts with JTS enabled driver, and transaction manager JTA interacts with JTS enabled driver. JTS enabled driver interacts with DBMS. And entity EJB interacts with JNDI here, and JNDI interacts with session EJB, and JNDI interacts with message driven EJB, and topic and queue are connected to message driven EJB. Topics and queue are inside JMS server. Message driven EJB is connected to session EJB. Here you can see EJB architecture, where enterprise beans fit in the J2E environment. The Sun Java System Application Server, we are talking about the older version now. The Sun Java System Application Server reduces the complexity of developing middleware by providing automatic support for middleware services such as transactions, security, database connectivity, and more. Uh, the following figure illustrates where enterprise beans fit in the J2EE environment. In the figure, the client machine is running a web browser or application client. The J2EE server machine is running on hosting the Sun Java system application server, and the database server machine hosts the databases such as Oracle and LDAP. Enterprise beans reside in the business tier with Java server pages, JSP pages, and servlets providing the interface to the clients, into the client tier, and the Sun Java application and the Sun Java system application server managing the relationships between the client and the database. Between the client and the database machines. The Sun Java system application server is responsible for providing the base of the EJB execution systems, which include the standard set of EJB services, distributed transaction management services, a means of data store access or backed system connection, an EJB container to implement the management and control services for EJB classes. So this description is going on with the EJB 2.0 actually, a bit older version here, but I included the this EJB 2.0 architecture here. Here you can see a client tier. Is inside the client machine there, and you can see application client and dynamic HTML pages are in client tier. This is J2E application 1 and J2E application 2 here. Below dynamic HTML pages, you can see JSP pages. JSP pages are in web tier, and below JSP pages and application client, you can see enterprise beans. Enterprise beans are in business tier, web tier, and business tier are in J2E server machine. And here below enterprise beans, you can see databases. Databases are in EIS tier. EIS tier is in database server machine. Here you can see the further details of J2E environment in EJB architecture. Here we are considering EJB 2.0 here, bit older version with this diagram. Here you can see client layer, browsers and web service client, application client container, and JMS clients are inside the client layer. JSP servlets, HTML are inside the web container, which is presentation layer. EJBs and MDB are in EJB container here. EJB container is in business logic layer. JDBC connectors are in data access layer, and RDBMSs and legacy applications are in data layer here. client layer is in client, presentation layer, business logic layer, and data access layer are in the server. Data layer is in EIS. Here browser interacts with JSP, and the browser in the client layer interacts with JSP, and the JSP interacts with servlets in web container here. Servlets interacts with EJB in EJB container, and EJB interacts with JDBC and connector and other EJBs, and here JDBC is interacts with RDBMS, and here connectors, EJBs interacts with connector, and connector interacts with legacy application. Here browser interacts with JSP, and JSP interacts with servlet. Here browser interacts with HTML, and HTML interacts with servlets. Here web service client interacts with servlet, and servlets interacts with EJB. EJB interacts with other EJBs. Here RMI and IIOP client in application client container interacts with EJB, and EJB interacts with MDB, and EJB interacts with connector. Connector interacts with legacy application. Here JMS client interacts with JMS provider. JMS provider interacts with MDB. MDB interacts with EJBs, and connector interacts with legacy application. Here you can see EJB flow. When a user invokes some Java system application server servlet from a browser, servlet may invoke one or more enterprise beans. For example, servlet may load the Java server page JSP to the user browser to request a username and password, then pass the user input to a session bean to validate the input. After valid user name and password combination is accepted, servlet might instantiate one or more entity and session beans to run the application's business logic, then terminate. The beans themselves might instantiate other entity or session beans to do further business logic and data processing. Here you can see a servlet or JSP user interface, and application clients interacts with EJB business logic. EJB business logic interacts with DB. Here you can see EJB container. Enterprise beans always work within the context of a container. The container serves as a link between the enterprise beans and the hosting server. The EJB container enables distributed application building using your own components and components from other suppliers. Through the container, the Java system application server provides high-level transaction management, state management, persistence, multi-threading, and resource pooling wrappers, thereby shielding you from having to know the low-level API details. By handling concurrency, the container shield you from worry about entities, hence threads simultaneously accessing the enterprise bean. This container provides all the standard container services denoted by the enterprise Java Bean specification version 2.0. and also provide additional services specific to Sun Java System Application Server here. The Sun Java System Application Server services include remote access, naming service, security service, concurrency, transaction control, and database access. The following figure illustrate the EJB container provided by Sun Java System Application Server. Here you can see EJBs and transactions, JDB, transactions, DB, persistence, naming, remote access, security, and concurrency are inside the EJB container. EJB container is inside Sun Java System Application Server. Here you can see a local interface, a local client connecting through the local interface, local interfaces within the two enterprise beans in a container. A local interface and local home interface provides a mechanism for a client that is located in the same Java virtual machine a JVM with the session or entity bean to access the bean. This provides a local client view. A local client may be tightly coupled to associated beans. Session and entity beans can have many local clients. The container provides the class that implements the local home interface and local interface. The objects that implement these interfaces are local Java objects. The local client view of EJB is not location independent. This diagram shows a local client connecting through the local interfaces within two enterprise beans in container. The local interface may be defined for a bean during development to allow streamlined calls to a bean if a caller is in the same container. Here you can see EJB local home and EJB local objects. Here you can see EJB object and EJB home. They are in the container, and container is in container, and the client are in the Java virtual machine. Here you can see Java EE containers. Since day one, the Jakarta EE has been based on. You can see Jakarta EE containers. Since day one, Jakarta EE has been based on containers. If you are in any doubt about this, just have a look at this diagram. In Java EE architecture, it belongs to Oracle form official documentation for Java EE and E6 and has been much the same architecture since the times of Sun. It's here to show that this is not new at all. As you can see, there are different containers: web container, an enterprise Java bean EJB container and an application client container. In other words, the application developed under those containers will rely on many features and services provided by them. When we take a Jakarta EE application, when we take a Jakarta EE application server and put it inside the Docker container, we are doing the same thing. It is relying on the some of the features and services provided by Docker environment. Here you can see the browser and application client container are inside client system. Browser interacts with the web container. Web container and EJB container are inside the Java EE server. So Java server faces and servlets are inside web container. Web container interacts with the EJB container. EJBs are inside EJB container. Application client is inside application client container, and application client container interacts with EJB container. EJB container interacts with the database. Here you can see the EJB directory structure in NetBeans, the standard directory structure of the enterprise Java Bean application. So I'm going to explain the standard directory structure of EJB application. This figure is given. This figure is taken from NetBeans IDE. Here the in the given here the new SEP is the application name of the project which we have created. The other files which are created, I'm going to describe these files. Manifest.mf. This is the file which provides meta information for the jar. This file is a standard component of jar file. It is used to extend the class path that is being used by EJB module. News app -ejb.jar. This is the jar file which is used for compressing, packaging and delivering several files together. The use of jar file in EJB is to package all the interfaces and classes that are associated with beans info associated with beans into one file. This file contains the following files: XML deployment descriptor, bean classes, remote 10 bean classes, remote 10 home interfaces, primary key classes and interfaces. newsapp.-var.var. This is the file in which we deploy the EJB remote interfaces and stub classes. This includes the EJB client classes. newsapp-EJB. This is the EJB module where we have stored the beans and interfaces. newsapp-var. This is the web module for our project. We have created the servlet and JSP pages. here the standard directory structure of the enterprise bean application. You can see this. Here you can see news app, and under news app you can see here you can see news app and news app dash EJB and news app dash WA. Here under news app you can see configuration files. Inside configuration file you can see manifest.mf, and here you can see server resources and Java E modules are inside news app. Inside Java E modules you can see news app dash ejb.jar and news app dash wa.wa. Inside news app dash EJB you can see enterprise beans, configuration files, server resources, source packages, test packages, libraries and test libraries. Under source packages you can see EJB. Under EJB you can see a new message bean.java, news entity Java, news entity facade Java, news entity facade local Java. Inside news app.wa you can see web pages, configuration files, server resources, source packages, test packages, libraries and test libraries. Inside source packages you can see web. Inside web you can see listnews.java and postmessage.java. Now we are focusing on EJB client. When one enterprise bean, call it the source enterprise bean, accesses another enterprise bean, call it the target enterprise bean, the source enterprise bean is the client of the target enterprise bean. If you are using EJB 3.0 with annotations and dependency injection, OC4J initializes the instance variable that corresponds to the target reference. If you are using EJB 2.1, you must use JNDI lookup in this scenario. Here you can see the composition of an EJB home proxy in JBoss. Let's begin our tour of the EJB container by looking at the client view of an EJB through the home and remote proxies. It is the responsibility of the container provider to generate the javax.ejb.ejb home and javax.ejb.ejb object for an EJB implementation. A client never references an EJB bean instance directly, rather it references EJB home. Which implements the bean home interface and EJB object. Which implements the bean remote interface. This figure shows the composition of EJB home proxy and its relationship to the EJB deployment. Here you can see the EJB developer, EJB deployer, org.jboss.ejb.ejb deployer is invoked to deploy an EJB jar. An EJB module org.jboss.ejb.ejb module is created to encapsulate the deployment metadata. The create pace of EJB module lifecycle creates an EJB proxy factory org.jboss.ejb.ejb proxy factory that manages the creation of EJB home and remote interface proxies based on the EJB module invoke a proxy binding metadata. There can be multiple proxy factories associated with an EJB, and we will look at this more closely shortly. The proxy factory construct the logical proxies and bind the home into JNDI. A logical proxy is composed of a dynamic proxy, java.lang.reflect.proxy, and the home interface of the EJB that proxy exposes, the proxy handler, java.lang.reflect.invocation handler, implementation in the form of client container, org.jboss.proxy.client container, and the client side interceptors. The proxy created by the EJB proxy factory is a standard proxy. It is a serializable object that proxies the EJB home and remote interfaces as defined in the EJB module metadata. The proxy translate the request made through the strongly typed EJB interface into the D-type invocation using client container handler associated with the proxy. The dynamic proxy instance is bound into JNDI as the EJB home interface that clients look up. When a client does the lookup of a EJB home, the home proxy is transported into the client VM along with the client container and its interceptors. Using dynamic proxies, avoid the EJB specific compilation step required by many other EJB containers. The EJB home interface is declared in the EJB-jar.xml descriptor and is available from the EJB module metadata. A key property of dynamic proxies is that they implement the interfaces that expose. This is true in the sense of Java's strong typing system. A proxy can be cast to any of the home interfaces. The reflection on the proxy provides a full details of the interfaces it proxies. A proxy delegates calls made through any of its interfaces to the client container handler. A single method required of the handler is public object invoke, object proxy, method dem, object array args, throws a throwable. The EJB proxy factory create client container and assign this as a proxy handler. The client container state consists of an invocation context, org.jboss.invocation.invocation context, and chain of interceptors, org.jboss.proxy.interceptor. The invocation context contains following: the JMX object name of the EJB container M being that the proxy is associated with, the JavaX EJB metadata for the EJB, the JNDI name of the EJB home interface, the transport specific invoker org.jboss.invocation.invoker. Interception chain consists of the functional units that make up the EJB home and remote interface behavior. This is a configurable aspect of an EJB. An interceptor and the interceptor makeup is contained in the EJB module metadata. Interceptors org.jboss.proxy.interceptor handle the different EJB types security, transactions, and transport. You can add your own interceptors as well. The transport specific invoker associated with the proxy has an association to the server side detached invoker that handles the transport details of the EJB method invocation. The detached invoker is a JBoss server side component. You configure the client side interceptors by using jboss.xml client interceptors element. When the client container invoke method is called, it creates an untyped invocation org.jboss.invocation to encapsulate request. This is then passed through the interceptor chain. The last interceptor in the chain is the transport handler that knows how to send the request to the server and obtain reply, taking care of the transport specific details. Here you can see EJB deployer is connected to EJB module, and EJB module is connected to proxy factory. Proxy factory is connected to proxy. Proxy and client containers are inside logical EJB proxy. Proxy interacts with EJB home. Proxy interacts with client container. Client container interacts with JBoss server. You can, as an example, you can see a client application. Here invoking EJB method, if you consider that part. Once you have the home interface, for the bean, you can invoke one of the beans create methods to instantiate a bean. Here, for example, then you can invoke EJB's methods in the normal way. Here you can see localhost colon 2481 colon OCRL here. Here, for example, we can employee number is here for example, for Alan, for instance. And here you can see the lookup bean, and here create a bean instance, and create a slot for the incoming data. And get the data and print it here. As an example too, you can see an example of EJB client code. This shows the source code for the sample EJB client application that is part of the VSE connector client. The code is based upon the use of the WebSphere application server as the web application server type. Here define properties specifying IIOP :// as the provider URL causes the EJB client to search for a name server on the localhost listening on the port number 900, which is the default for the WebSphere application server. In real environment, you would specify the complete URL such as IIOP : / bank server .mybank.com : 9019. Here you can see the initial context object is instantiated. Here the home interface of the employer bean is looked up. The string used here to identify the EJB is stored in the EJB's deployment descriptor. You can view the EJB's deployment properties by using WebSphere Administrative Console. Here you can see create a remote interface object to obtain access to the EJB's business logic methods. This call to the remote interface create method invokes the EJB create method of the EJB. Here access the EJB's business logic methods. For example, get some properties of employer 103, employer that has the number 1003. Please be aware, however, that is the EJB is always accessed via the remote object. In this example, employer.class in this example, employee number and password are taken from the EJB sample provided with the VSE connector client, which also provide the utilities to fill the sample VSAM cluster with some simple sample data. In this code, you can see an example that configures the EJB client connections, global interceptors, and invocation timeouts using the EJB client element in the wildfly config .xml file. You can use the JBoss dash EJB dash client element, which is in the URN colon wildfire dash client dash EJB colon 3.0 namespace. To configure EJB client connectors, EJB client connections, global interceptors, and invocation timeouts using the wildfly-config.xml file. Invocation timeout. This optional element specifies the EJB invocation timeout. It has seconds attribute. The timeout in seconds for EJB handshake or the method invocation request response cycle. This attribute is required if the execution of a method takes longer than the timeout period. The invocation throws java.util.concurrent.timeout exception. However, the server side will not be interrupted. Global dash interceptors. This optional element specifies the global EJB client interceptors. It can contain any number of interceptor elements. Interceptor. This element is used to specify an EJB client interceptor. It has class and module attributes. Class attributes: the name of a class that implements org.jboss.ejb.client.ejb client interceptor interface. This attribute is required. Module attribute: the name of the module that should be used to load the interceptor class. This attribute is optional. Connections. This element is used to specify EJB client connections. It can contain any number of connection elements. Connection. This element is used to specify an EJB client connection. It can optionally contain interceptors element. It has a URI attribute. URI attribute: the destination URI for the connection. This attribute is required. Here we are considering a session being exposing multiple client views in access in the global JNDI namespace. If a shared bean is packaged in shared.jar without a deployment descriptor, deployed as a standalone module, the resulting global JNDI names entries are here. Now we are considering client view of a message-driven bean in message-driven bean component. For example, the reference to the queue for Jakarta messaging message-driven bean might be injected as follows here. Alternatively, the queue for stock info Jakarta messaging message-driven bean might be located using following code segment here. Now we are considering client managed demarcation in sample scenarios in support for transactions. A Java client can use Jakarta.transaction user transaction interface to explicitly demarcate transaction boundaries. Client program obtains the Jakarta.transaction.user transaction interface through dependency injection or lookup in the beans EJB context or in the JNDI namespace. Now we are considering the client view of exceptions in exceptions handling. A client accesses an enterprise bean either through the methods of business interface typically do not throw the java.rmi.remote exception regardless of whether the interface is a remote or local interface. A client accesses an enterprise bean either through the enterprise beans business interface, whether local or remote, through the enterprise beans no interface view, through the enterprise beans remote home and remote component interfaces, through the enterprise beans local home and local component interfaces, or through the enterprise beans web service client view, depending on whether the client is written to the enterprise beans 3.x API or earlier API, and whether the client is a remote client, a local client, or a web service client. The methods of the business interface typically do not throw the java.rmi.remote exception regardless of whether the interface is a remote or local interface. The remote home interface and the remote component interface are Java RMI interfaces, and therefore the throws clauses, all their methods including those inherited from super interfaces, include the mandatory java.rmi.remote exception. The throws clause may include an arbitrary number of application exceptions. The local home and local component interfaces are both Java local interfaces, and the throws clause, all their methods including those inherited from super interfaces, must not include the java.rmi.remote exception. The throws clauses may include an arbitrary number of application exceptions. The no interface view is a local view, and the throws clauses of all methods must not include the java.rmi.remote exception. The throws clauses may include an arbitrary number of application exceptions. Now we are considering enterprise beans clients responsibilities in security management. These rules are here. Here we are considering we are defining the rules and that enterprise beans client program must follow to ensure that the security context passed on the client calls and the possibly imported by the enterprise bean do not conflict with the enterprise bean server capabilities for association between the security context and transactions. The rules are a transaction client cannot change its principal association within a transaction. This rule ensures that all calls from the client within a transaction are performed with the same security context. A session beans client must not change its principal association for the duration of the communication with the session object. This rule ensures that the server can associate a security identity with the session instance at instance creation time and never have to change the security association during the session instance lifetime. If transactional requests within a single transaction arrive from multiple clients, this could happen if there are intermediary objects or programs in the transaction call chain. All requests within the same transaction must be associated with the same security context. Now we are considering clients written to the enterprise bean 2.text APIs in interoperability of enterprise beans 3.2 and earlier components in compatibility and migration. And enterprise beans that is written to the enterprise beans 2.1 or earlier API release may be a client of components written to the enterprise beans 3.x API using the earlier enterprise beans APIs when deployed in an enterprise beans 3.x container. Such an enterprise beans 2.1 or earlier client component does not need to be rewritten or recompiled to be a client of a component written to the enterprise bean 3.x API. Such clients may access component written to the enterprise bean 3.x APIs and component written to the earlier enterprise beans API within the same transactions. Now we are considering clients written to the enterprise bean 3.x API. A client written to the enterprise bean 3.x API may be a client of a component written to the enterprise bean 2.1 or earlier API. Such clients may access component written to the enterprise bean 3.x APIs and components written to the enterprise beans APIs within the same transaction. Such client access component written to the earlier enterprise beans APIs using the enterprise bean 3.1 client view home and component interfaces. The EJB annotation or the EJB ref and EJB local ref deployment script elements may be used to specify the injection of home interfaces into component that are client of beans written to the enterprise beans client view. Now we are considering client programmers' responsibilities and responsibilities of enterprise bean roles. The enterprise beans client programmer writes applications that access enterprise beans via their business interfaces, via their no interface view, via their web service client view, or via messages, or view their home and component interfaces. Example. We can consider no class def found exception, no class def found exception, class not found exception. If the client issues either of these, there is probably something missing or corrupt on your client side class path. The exception should give you a good indication of which class is missing, and from this you may be able to work out which jar file to add to the class path. Remember that you need j2ee.jar and the fully deployed jar in the class path. It is unlikely that CICS will issue any useful additional information for these problems. No class found error :javax/EJB/home handle. This indicate that a client application does not have EJB 1.1 level classes available on the class path. Ensure that j2ee.jar is available. These things are under CICS transaction server for Z/OS. And then as an error example, we can consider getting EJB client 000025 error if a EJB is called on a remote JBoss EAP server. Here you can see the error java.lang.illegal state exception, EJB client 000025, no EJB receiver available for handling, app name : remote test remote, module name : EJB, distinct name, and combination for invocation context, etc. Now we are focusing on Oracle 8 type. Oracle database, commonly referred to as Oracle DBMS or simply as Oracle, is a multi-model database management system produced and marketed by Oracle Corporation. Here you can see Oracle database architecture on Windows. The Oracle database architecture on Windows, here an Oracle instance is shown as a Windows service, a background process registered with the operating system. The service is started by Windows and requires no user interaction to start. It contains memory structures and threads needed to access the database. The client connects via a shadow thread to the Oracle instance. The shadow thread connects directly with the process monitor. The memory structured inside a shared pool of a library cache and a data dictionary cache. A database buffer cache and a redo log buffer. The threads includes database writer, log writer, process monitor, system monitor, all required while the database is available, checkpoint process, archive process, and distributed recovery process, all optional while the database is available. There is an Oracle database containing data files, control files, and redo log files. Associated with the database is the parameter file, password file, and archived log files. The internal process architecture of Oracle database is thread-based. Threads are objects within a process that run program instructions. Threads allow concurrent operation within a process that a process can run different parts of its program simultaneously on different processes. A thread-based architecture provides following advantages: faster context switching, simpler system global area allocation routine because it does not require use of shared memory, faster spawning of new connections because threads are created more quickly than processes, decreased memory usage because threads share more data structures than processes. Internally, the code to implement the thread model is compact and separate from the main body of the Oracle database code. Exception handlers and routings track and deallocate resources. They add robustness with no downtime because of resource leaks or ill-behaved program. Oracle database is not a typical Windows process. On Windows, or an Oracle database instance, threads and memory structures is a Windows service, a background process registered with operating system. The service is started by Windows and requires no user interaction to start. This enables the database to open automatically at startup. When running multiple Oracle database instances on Windows, each instance runs on its own Windows service with multiple component threads. Each thread may be required for the database to be available, or it may be optional and specific to certain platforms. The background processes read and write from various data files depending on your configuration. Oracle database architecture, you can see here. Here you can see required and optional database threads. DBWO is database server, the database writer. It is required. LGWR, log writer, it is required. PMON, process monitor, it is required. SMON, system monitor, it is required. CKPT, checkpoint process, thread on Windows, that runs by default on Windows. This is optional. ARCH and 0, archive process on thread on Windows, optional. This is optional. RECO, distributed recovery background process, and this is optional. You can view background. You can view running background processes by issuing follow this SQL command. Select asterisk from $BG process where PADDR less than, greater than, comma 00, comma semicolon. Oracle database for Windows is supplied as a set of executable and dynamic link libraries, DLLs. Executable images can be modified using ORA stack to change the size of the stack used by the threads of the Oracle database process. Oracle recommends you use this tool only under guidance of Oracle support services. When we consider file and OS enhancement, Oracle database supports 64-bit I/O to allow use of larger than 4 gigabytes GB. In addition, physical and logical raw files are supported as data, log, and control files. To support Oracle real application clusters on Windows, and for those use cases where performance need to be maximized. All Oracle database file I/O routine supports 60-bit offsets, meaning there are no 2GB or 4GB file size limitations when it comes to data, log, or control files, as there are on some other platforms. In fact, the limitations that are in place are generic Oracle database limitation across all platforms. These limits include 4 million database blocks for each file, 60 KB maximum block size, and 64K files for each database. If these values are multiplied, then maximum file size for database file on Windows is 64 GB. The maximum total database size supported with 16 KB database blocks is 4 petabytes. Raw file support. Windows supports raw files similar to Unix. Using raw files for database or log files can have a slight performance gain. Raw files are unformatted disk partitions that can be used as one large file. Raw files can have benefits of no file system or backing up raw files. As a result, raw files generally used only by high-end installation and by Oracle real application clusters where they are required. To Oracle database, raw files is no different from other Oracle database files. They are treated in the same way by Oracle database as any other file and can be backed up and restored through Recovery Manager or OCOPY. Here you can see a client thread here. Client thread interacts with shadow thread. Shadow thread interacts with process monitor. Shadow thread and memory structures are inside Oracle instance, and system global area is also inside Oracle instance, and system global area consists shared pool, database, buffer cache, redo log buffer, and shares library cache and data dictionary are inside shared pool. Oracle instance interacts with recoverer, system monitor, database writer, and Oracle instance is connected to process monitor, checkpoint, log writer, archiver, and Oracle database data files, control files, and redo log files are inside Oracle database, and Oracle data and there are parameter file, password file, and archive log files also. Here you can see basic EJB component relationships. There are 4 major components that you must create to develop a complete EJB: home interface, remote interface, implementation of a remote interface, the actual bean class, and a deployment descriptor for each EJB. The home interface specify the interface to an object that the container itself implements. The home object, the home interface contains create methods that specify how a bean is created. Home interface with home object serves as a factory object for EJBs. Remote interface specify the method that you implement in the bean. These methods perform the business logic of the bean. The bean must also implement the additional service method that the EJB container calls it various times in the life cycle of a bean. the Bean implementation contains the Java code that implement the remote interface and required container methods. Deployment descriptor specified attributes of a bean for deployment and loading into the database. For example, the deployment descriptor declares the transactional properties of the bean. At deployment time, the EJB deployer, together with the application deployer, can decide whether the container should manage transaction support or have the client to do it. Client application itself does not access the bean directly. Rather, the container generates a server-side object known as EJB object that serves as a server-side proxy for the bean. The EJB object received the message from the client thus the container can interpose its own processing before the messages are sent to the bean implementation. Here you can see a client is connected to home interface. Create is passed from client to home interface, and invoke methods are passed from client to remote interface. Server container and Oracle 8i are inside the server. Home interface, remote interface, and bean instance are inside the container. Home interface is connected to bean instance. And remote interface is connected to bean instance, and bean instance is connected to Oracle 8i database. As an example, we can consider deployment steps. The format used to the package EJBs is defined by the EJB specification. This section describes the steps that the EJB developer and the EJB deployer take to compile, package, and deploy an EJB. Oracle 8i supplies a deployment tool, Deploy EJB, that automatically performs most of the steps necessary to deploy an EJB. The Deploy EJB tool deploys only one bean at a time. Step 1. Compile the code for the bean. This includes home interface, remote interface, bean implementation. All Java source files dependent on the bean implementation class. This dependency is normally taken care of by the Java compiler. Use the standard client-side Java compiler to compile the bean source files. The bean typically consists of one or more Java source files and might have associated resources files. Oracle 8i supports the Sun Microsystems Java Developers Kit compiler versions 1.1.6 or 1.2. Alternatively, you might be able to use another JCK tested Java compiler to create EJBs to run in the Oracle 8i server. Step 2. write the XML deployment descriptor for the EJB. Step 3, write the Oracle deployment mapping file. Step 4, create a jar file containing the interface and implementation class files, the home interface, the remote interface, and the bean implementation for the bean. If you have other dependent classes and resource files, it is better to create a separate jar file for these. Deploy EJB tool uses this jar file as an input file. Step 5, call the deploy EJB tool. See Oracle 8i Java reference tools reference for information on deploy EJB to load and publish the jarred bean. As an error example, we can consider this one: publish error on deploying EJB on Oracle 8i. Publish oracle.aurora.server.tools .scss underscore iiop dot tools exception cannot create directory, no access right. This is occurred in Oracle 8i and Windows NT 4.0. Now we are focusing on sessions. A session bean is an EJB 3.0 or EJB 2.5 enterprise bean component created by a client for the duration of a single client server session. A session bean performs operation for the client. Although a session bean can be transactional, it is not recoverable should a system failure occur. Session bean objects are either stateless or stateful, maintaining conversational state across method calls and transactions. If a session bean maintains state, then OC4J manages this state if the object must be removed from the memory. However, the session bean object itself must manage its own persistent data. Here you can see a sequence of events in a session bean lifecycle. An enterprise Java bean has two client interfaces, a remote interface and a home interface. Remote interface specifies the methods that the object's client can invoke. The home interface defines how clients can create objects, which returns the reference to the objects. The client uses both of these interfaces when invoking a method on a bean. The events that occur when a client invokes a method within a bean are explained in this diagram. The numbers here are correspond to the steps. Step 1, during client 1. Step 1, client 1 lookups home interface for bnex. During JNDI lookup, the database create a session for the server side of the request. reference to home interface X is returned to the client 1. Client 1, step 3, client 1 invokes create method on home interface X. The bean instance is created within the session that was established on the GNDI lookup. Home interface X instantiate the remote interface X and contain the container instantiate a bean for this client and is destroyed only when a client invokes the remove. The object reference of the remote interface X to invoke methods on bean instance X. The object reference of remote interface X is returned to the client 1. Client 1 uses step 5. Client 1 uses remote interface X to invoke methods on bean instance X. Steps 6. Remote interface X delegates call to a bean. Step 7. Client interface client 1 invokes remove on remote interface. When it's done with the bean instance, this destroys the remote interface and the bean instance. Here you can see a client is connected to remote home interface and remote interface. Create is passed from client to home interface and invoke methods are passed from client to remote interface. Oracle 9 database and container are inside server. Container consists of here home interface and remote interface, and bean instance are inside container. Home interface is connected to bean instance. EJB create is passed from home interface to bean instance. Remote interface is connected to bean instance. Bean instance is connected to Oracle 9 database here. Here you can see a stateless session bean life cycle. This figure shows the stateless session bean life cycle. There are two states: does not exist and method ready pull. To transition from does not exist to method ready pull, following occurs. New instance method is invoked. Dependency injection takes place, if any. Set session context method is invoked, and the session bean method annotated as post construct or the EJB create method, if defined, is invoked. To transition from the method ready to method ready pull to the does not exist state, following occurs. The session bean method annotated as pre-destroy or the EJB remove method, if defined, is invoked, while the method ready pull state session bean methods can be invoked as the EJB timeout method if the session bean implements the timeout interface. The life cycle for EJB 3.0 and EJB 2.1 stateless session beans are identical. The difference is in how you register lifecycle callback methods. The optional EJB 3.0 stateless session bean lifecycle callbacks method you can define using annotations. For EJB 3.0 stateless session beans, you do not need to implement these methods. Here you can see the lifecycle methods for an EJB 3.0 stateless session bean. Annotation at post construct. This optional method is invoked for a stateless session bean before the first business method invocation on the bean. This is at a point after which any dependency injection has been performed by the container. Annotation at pre-destroy. This optional method is invoked for a stateful session bean when the instance is in the process of being removed by the container. The instance typically releases any resource that has been holding. The EJB 2.1 lifecycle methods as specified in javax.ejb.sessionbean interface, that is stateful session bean, must implement. For EJB 2.1 stateful session beans, you must at least provide an empty implementation for all callbacks methods. EJB create method. The container invokes this method right before it creates the bean. Use this method to initialize non-client specific information such as retrieving a data source. EJB activate. This method is never called for a stateless bean session bean, providing an empty implementation only. EJB pursue. This method is never called for an stateless session bean, provide an empty implementation only. EJB remove. This container invokes this method before it ends the life cycle of a stateless session bean. Use this method to perform any required cleanup, for example, closing an external resources such as data source. Set session context. The container invokes this method after it first instantiates the bean. Use this method to obtain a reference to the context of the bean. Here, a stateless bean is a session with no conversational state. All instances of a particular stateless session bean class are identical. Here you can see does not exist interact with method ready pool, and it interacts with method and EJB timeout. Methods and EJB timeouts are passed here. New instance, then dependency injection, then set session context, then at post construct or EJB create are passed from does not exist to method ready pool. Pre-destroy or EJB remove is passed from method ready pool to does not exist. Here you can see a stateful session bean life cycle. Stateful session bean is a session bean that maintains conversational state. This figure shows the stateful session bean life cycle. There are 4 states: does not exist, method ready, in transaction, and passive. To transaction from does not exist state to the method ready state, following occurs: the new instance method is invoked, dependency injection occurs if any, and the session bean method is annotated as the pre-construct, or the EJB create method, if defined, is invoked. The transaction from the method ready state to passive state, the container chooses the session bean as eligible for passivation, and the following occurs: session bean method annotated as pre-passive or EJB passive method if defined invoked. The transition from passive state back to the method ready state, the following occurs: session bean method annotated as post activate, or the EJB activate method is, if defined, is invoked. If the session bean remains in the passive state long enough to exceed the passivation method timeout, the session bean moves to the does not exist state. To transition from method ready state to the method ready in transition state, the following occurs: a transition is started from the method ready state to the method ready transition state. A transition is started and the session synchronization method after begin is invoked. To transition from method ready in transaction state back to the method ready state, the following occurs for the success case: the transaction commits successfully, session synchronization method before compilation is invoked, the session synchronization method after compilation is invoked with an argument of true. The following occurs for the failure case: the transaction is rolled back and the session synchronization method after completion is invoked with the argument of false. Annotations such as post construct are applicable to EJB 3.0 stateful session beans only. EJB, the lifecycle for EJB 3.0 and EJB 2.1 stateful sessions beans are identical. The difference is in how you register lifecycle callback methods. The optional EJB 3.0 stateful session bean lifecycle callback methods you can define using annotations. For EJB 3.0 stateful session beans, you do not need to implement these methods. So annotation post construct. This option method is invoked for a stateful session bean before the first business method invocation on the bean. This is at the point after which any dependency injection has been performed by the container. Pre-destroy, annotation pre-destroy. At this point, this optional method is invoked for the stateful session bean while the instance is in the process of being removed by the container. The instance typically releases any resources that it has been holding. Annotation at pre-pursue. The container invokes this method right before it pursuates a stateful session bean. Annotation at post activate. This container invokes this method right after it reactivates formerly pursuated stateful session bean. EJB 2.1 lifecycle methods as specified in the javax.ejb.session bean interface that a stateful session bean must implement. For EJB 2.5 stateful session beans, you must at the least provide an empty implementation for all callbacks methods. EJB create method. The container invokes this method right before it creates the bean. Stateless session beans must do nothing in this method. Stateful session beans can instantiate state in this method. EJB activate method. The container invokes this method right after it reactivates the bean. EJB pursuate method. The container invokes this method right before it pursuates the bean. EJB remove method. A container invokes this method before it ends the life of session bean, life of a session object. This method performs any required cleanup, for example, closing external resources such as file handles. And set session context method. This container invokes this method after it first instantiates the bean. Use this method to obtain reference to the context of the bean. Here you can see does not exist interacts with method ready, new instance, then dependency injection, then post construct annotation or EJB create method are passed from does not exist to method ready, and from method ready to remove or EJB timeout, then at pre-destroy annotation or EJB remove are passed from method ready to does not exist. Method ready interacts with passive. At pre-passive annotation or EJB pursuate method are passed from method ready to passive. Post activate annotation or EJB activate method is passed from passive to method ready. Passive is connected to does not exist state. timeout is passed from passive to does not exist. Non-transaction TX method is connected from method ready to method ready. Method ready interacts with method ready in transaction. Transaction method, then after begin method passed from method ready to method ready in transaction. Commit, then before completion, then after completion true are passed from method ready to TX. Method ready in transaction to method ready. Rollback, then after completion false are passed from method ready in transaction to method ready. As an example, we can here you can see session bin example objects. An example of the session bin runtime objects is illustrated by this diagram. Client obtains a reference to cart session object which provides a shopping service by means of a dependency injection or using JNDI lookup. The client then uses this session object to fill the cart with items and to purchase its contents. Its contents. Cart is a stateful session bin. It's a stateful session. In this example, the client obtains a reference to the cart's business interface through dependency injection. The client then uses the business interface to initialize the session object and add a few items to it. The start shopping method is a business method that is provided for the initialization of the session object. Finally, the client purchases the contents of the shopping cart and finishes the shopping activity. You can see client is connected to cart. Cart interacts with the container. Cart is connected to cart bin here. Here you can see the web service client view of the stateless session beans deployed in a container. From the perspective of the client, the existence of the stateless session bean or singleton session bean is completely hidden behind the web service endpoint. The web service client's access to the web service functionality provided by a session bean occurs through a web service endpoint. In the case of Java client, this endpoint is accessed as a Jakarta XML web services service endpoint using the client views API. The following diagram illustrates the view that is provided to Jakarta XML web services client of stateless session bean through the client view APIs. Here you can see the client is connected to service class and web service endpoint. Service class interacts with container and web service interacts. Web service endpoint interacts with the container and stateless session bean. Stateless session bean is inside container. Stateless session bean instances are inside stateless session bean. Here you can see life cycle of a session object. From the point of view of a local or remote client using Enterprise Beans 2.1 and earlier client view API, the life cycle of a session bean is illustrated here. The session bean does not exist until it is created. When client creates a session object, the client has a reference to the newly created session object component interface. References to session object remote component interface. A client has a reference to a session object's remote component interface can then do any of the following: invoke business method defined in the session object remote component interface, get a reference to session object's remote home interface, get a handle for the session object, pass a reference to as a parameter or return value within the scope of the client, remove the session object. A container may also remove the session object automatically when the session object lifetime is expired. It is invalid to reference a session object that does not exist. Attempted remote invocation on a stateful session object that does not exist result in Java .rmi. No such object exception. References to session object local component interface. A client that has a reference to a session object local component interface can then do any of the following: invoke business method defined in the session object's local component interface, get a reference to a session object's local home interface, pass a reference to as a parameter or return a value of the local component interface method, remove the session object. A container may also remove the session object automatically when the session object lifetime expired. It is invalid to reference session object that does not exist. Attempted invocations on a stateful session object that does not exist result in Jakarta.EJB. No such object local exception. A client can pass a local object reference or local home object reference to another application through its local component interface. A local object reference or local home object reference cannot be passed as an argument or result of a method on an Enterprise Beans remote home or remote component interface. So here you can see does not exist and not reference is connected to exist and referenced via home.create method. Exist and referenced is connected to itself via client's method on reference. Here exist and not reference is connected to exist and reference via handle.get EJB object method. Exist and reference is connected to exist and not reference via release reference. Exist and not reference is connected to does not exist and not reference via container crash or bean timeout. Here exist and reference is connected to does not exist and reference via object to remove home.object.remove method, home.remove method. System exception in bean timeout or container crash. Does not exist and reference is connected to itself via client's method on reference generates no such object exception or no such local object exception. Does not exist and reference is connected to does not exist and not reference via release reference. Here you can see session bean example objects. An example of session bean runtime objects is illustrated by the following diagram here. A client create a remote cart session bean session object which provides a shopping service using create method of the cart's remote home interface. The client then uses this session object to fill the cart with items and to purchase content. suppose that the end user wishes to start a shopping session. Suspend the shopping session temporarily for a day or two and later complete the session. The client might implement this feature by getting the session objects handle, saving the serialized handle in the persistent storage and using it later to re-establish the access to the original cart. For the following example, we start by looking up the cart's remote home interface in JNDI. We then use the remote home interface to create a cart. Create a cart session object and add few items to it. Next, we decide to complete this shopping session at a later time. So we serialize a handle to this cart session object and store it in a file. Finally, we deserialize the handle at the later time recreate the reference to the cart session object and purchase the contents of the shopping cart. Serialize cart handle store in a file. Deserialize from a file. Here you can see client is connected to cart and cart home. Cart and cart home interacts with container. Cart is connected to cart bin and cart home is connected to cart bin here. Cart bin is inside the container. Now we are considering life cycle of a singleton session bean. A singleton session bean is a session bean component that is instantiated once per application. In case where the container is distributed over many virtual machines, each application will have one bean instance of the singleton for each JVM. Once instantiated, the singleton session bean instance lives for the duration of the application in which it is created. It maintains its state between client invocation, but its state is not required to survive container shutdown or crash. A singleton session bean is intended to be shared and it supports concurrent access. A singleton session bean must not implement Jakarta.EJB.session synchronization interface or use session synchronization annotations. Following steps describe the life cycle of a singleton session instance. A singleton session bean instance life start with when the container invokes the session bean class constructor to create a singleton session bean. Singleton bean instance. Next, the container perform dependency injection as is specified by the metadata annotations on the bean class or by deployment descriptor. The container then calls the post construct lifecycle callback interceptor method for the bean if any. The singleton bean instance is now ready to be delegated a business method call from any client or a call from container to a timeout callback method. When the application is shutting down, the container invokes the pre-destroy life cycle callback interceptor method on the singleton session bean instance, if any. This ends the life of the singleton session bean instance. Here you can see does not exist interacts with method ready. Does not exist is connected to method ready. Step 1, around construct callbacks if any. 2, constructor. 3, dependency injection if any. 4, post construct callbacks if any. Method ready is connected to itself via method. Method is an action initiated by client. Method ready is connected to itself via timeout callback method. Method ready is connected to does not exist via pre-destroy callbacks if any. Here the constructor is an action initiated by the container. Here you can see transaction diamond scenario with the session bean. While it is illegal for two clients to access the same session object, it is possible for applications that use session beans to encounter the diamond case. For example, a program A starts a transaction and then invokes two different session objects. If the session object bean instances cache the same data item, for example, current balance of account 100, across method invocations in the same transaction, most likely the program is going to produce incorrect results. The problem may exist regardless of whether the two session objects are the same or different session beans. The problem may exist and may be harder to discover if there are intermediate objects between the transaction initiator and the session object that cache the data. There are no requirement for container provider for the container provider because it is impossible for container to detect this problem. The bean provider and application assembler must avoid creating applications that would result in inconsistent caching of data in the same transaction by multiple session objects. Here you can see a program A is connected to session instance 1 via TX1 and program A is connected to session instance 2 via TX1. Here session instance 1 and session instance 2 are inside enterprise bean container. Session instance 1 is connected to read and cache account 100. Session instance 1 is connected to database via read and cache account 100 here, and session instance 2 is connected to database via read and cache account 100 here. Here annotation type stateless. Component defining annotation for a stateless session bean. This is in package javax.ejb. This EJB version is 3.2. As an example 2, we can consider this code. Annotation type stateful. Component defining annotation for a stateful session bean. This is in package javax.ejb, EJB version 3.2. Here you can see set session bean access timeout values in as a XML configuration sample. This is in the environment of Red Hat JBoss Enterprise Application Platform 7.4. Now we are considering session objects in enterprise bean object types in overview. A typical session object has the following characteristics. Executes on behalf of a single client, can be transaction aware, updates shared data in an underlying database, does not represent directly shared data in the database, although it may access and update such data, may be relatively short-lived or may have the same lifetime as that of the application, is removed when the enterprise beans container crashes. The client has to re-establish a new session object to continue computation. A typical enterprise bean container provides a scalable runtime environment to execute a large number of session objects concurrently. The enterprise bean specification defines stateful, stateless, and singleton session beans. There are differences in the API between the stateful session beans and stateless session beans and singleton session beans. Now we are considering an overview, the client view. For a client, a session object is an non-persistent object that implements some business logic running on the server. One way to think of a session object is as a logical extension of the client program that runs on the server. A stateless and stateful session bean object is not shared among multiple clients. A client can invoke a session bean synchronously or asynchronously, and a asynchronous method can return a feature V object that allows the client to retrieve a result value, check for exceptions, or attempt to cancel an in-progress invocation. From its creation until destruction, a session object lives in a container. The container provides security, concurrency, transaction swapping to secondary storage, and other services for a session object transparently to the client. Each session object has an identity which, in general, does not survive a crash or restart of the container. Although a high-end container implementation can mask container and server crashes to a remote or web service client, a client never directly accesses instances of the session beans class. A client accesses a session objects through a session beans client view. The client view of a session object independent of the implementation of the session bean and the container. A client of a session bean may be a local client, a remote client, or a web service client, depending on views provided by the beans and used by the client. Multiple enterprise beans can be installed in a container. The container allows the clients of a session beans that provide local or remote client views to obtain the business interfaces and or home interfaces of the installed enterprise beans through dependency injection, or to look them up via JNDI. While it is possible to provide more than one client view for a session bean, typically only one will be provided. A remote client of a session bean can be another enterprise bean deployed in the same or different container, or it can be an arbitrary Java program such as an application, applet, or servlet. The client view of a session bean can also be mapped to non-Java client environments such as COBA clients that are not written in the Java programming language. The interface used by a remote client of a session bean is implemented by the container as a remote business interface or a remote EJB object interface. The remote client view of a session bean is location independent. A client running in the same JVM as the session object uses the same API as a client running in a different JVM on the same or different machine. Use of a session bean's local client view entails the collocation of the local client and the session. The local client of an enterprise bean must be collocated in the same container as the bean. The local client view is non-location independent. The client of a stateless session bean or a singleton session bean may be web service client. Only a stateless session bean or singleton session bean may provide a web service client view. A web service client makes use of enterprise bean's web service client view as described by the WSDL document. The bean's client view web service endpoint is in terms of Jakarta XML web services endpoint. Now we are considering local, remote, and web service client view. This specification distinguishes among the client view interfaces defined by the Enterprise Beans 3.0 and later API and Enterprise Beans 2.1 and earlier API as follows here. The Enterprise Bean 3.1 significantly simplified the client view of a session bean. The term remote business interface is used to refer to the business interface of an Enterprise Bean 3.x session bean that supports remote access. The term remote component interface is used to refer to the remote component interface of the Enterprise Bean 2.1 client view. This interface is an EJB object interface. The term local business interface refers to the local business interface of an Enterprise Bean 3.x session bean that supports local access. The term local component interface is used to refer to the local component interface of the Enterprise Bean 2.1 client view. This interface is an EJB local object interface. The term business interface is used to refer to a local or remote business interface. The term component interface is used to refer to a local or remote component interface. EJB local object or EJB object interface. The term business method is used to refer to a method of an Enterprise Bean that is available for client execution. It may be a method exposed by the local or remote business interface by the no interface view, by the local component interface, or by the remote component interface, or by web service client view. Now we are considering Enterprise Beans container. An Enterprise Beans container for short, is a system that functions as a container for Enterprise Bean. Multiple Enterprise Beans can be deployed in the same container. The container is responsible for making business interfaces and or home interfaces of its deployed Enterprise Beans available to the client through dependency injection or through lookup in the JNDI namespace. Now we are considering obtaining a session bean business interface in client view of a session beans returned to the Enterprise Beans 3.x simplified API. For example, the business interface cart for the cart bean session bean session bean may be obtained using dependency injection as follows here. The annotation type EJB indicates a dependency on the local no interface or remote view of an Enterprise Bean. This is in the package jakarta.ejb. The client can obtain a session beans business interface through dependency injection or lookup in the JNDI namespace. For example, a business interface cart for the cart bean session bean session bean may be obtained using dependency injection as follows here. The cart business interface could also be looked up using JNDI as shown in the following code segment using lookup method provided by EJB context. EJB context interface. In this example, a reference to the client bean session context object is obtained through dependency injection. In both cases, the syntax used in obtaining reference to a cart business interface is independent of whether the business interface is local or remote. In the case of remote access, the actual location of the reference Enterprise Bean and Enterprise Beans container are in general transparent to the client using remote business interfaces of the bean. Now we are considering Jakarta XML web services as clients in web service client view of a stateless or singleton session bean. The following example illustrates how a Jakarta XML web services how a Jakarta XML web services client obtains a reference to a web service endpoint, obtains a port object, for the web service endpoint and invokes a method on it on the endpoint. Jakarta and here you can see the annotation type web service ref. The web service ref annotation is used to define a reference to a web service and optionally an injection target for it. It can be used to inject both service and proxy instances. These injected references are not thread safe. If the references are accessed by multiple threads, usual synchronization techniques can be used to support multiple threads. This is in the module jakarta.xml.ws and the package jakarta.xml.ws. Jakarta XML Web Services client can obtain a reference to a web service instance of the jakarta.xml.ws.service class through independence injection or using JNDI. The service class can be generic jakarta.xml.ws.service class or a generator service class which extends jakarta.xml.ws.service class. The service instance is then used to obtain a port object for the service endpoint. The mechanisms and APIs for client web service access are described in the Jakarta XML web services in the documentation specification and in Jakarta Enterprise Web Services specification. The following example illustrates how a Jakarta Web Services client obtain a reference to a web service endpoint, obtains a port object for the web service endpoint and invokes a method on that endpoint. Use of service references and the web service ref annotations are, you can see here. Now we are considering locating a session bean's home interface in remote and local client view of a session beans returned to the Enterprise Bean 2.1 client view API. Locating a session beans, for example, an Enterprise Bean 3.x client com.acme.example.mysessionbean might obtain a reference to a bean's home interface as follows here. Enterprise Bean 2.1, an earlier specification required that the client first obtain a reference to a session bean home interface and then use the home interface to obtain a reference to bean's component interface. This earlier programming model continues to be supported by this specification. Both dependency injection and use of the EJB context lookup method may be used as an alternative to the JNDI APIs to obtain reference to the home interface. For example, an Enterprise Beans 3.x client com.acme.example.mysessionbean might obtain a reference to a bean's home interface as follows. This home interface could be looked up in the JNDI using EJB context lookup method as shown in the following segment. When the EJB context lookup method is used to look up the home interface, the use of javax.rmi.portable remote object.narrow is not required. The following code segment illustrates how the home interface is obtained when JNDI APIs are used directly as was required in the Enterprise Bean 2.1 programming model. For example, the remote home interface, the cart for example, the remote home session for the cart session bean can be located using the following code segment. If the cart session bean provides a local client view instead of a remote client view, the cart home is a local home interface. This lookup might be as follows here. Now we are considering overview in session bean component contract. A session bean may be either this. A session bean instance is an instance of a local. It's a session bean class. It holds a session object state. Session bean instance is an extension of the client that creates its. In the case of stateful session bean, its fields contain conversational state on behalf of the session object's client. This state describes the conversation represented by a specific client session object pair. It typically reads and updates the data in a database on behalf of the client. In the case of stateful session bean, its lifetime is controlled by the client. A container may also terminate a session bean interface's lives after a deployment specified timeout or as a result of the failure of the server on which the bean instance is running. For this reason, a client should be prepared to recreate a new session object if it loses the one it is using. Typically, a session object's conversational state is not returned to the database. A session beans provider simply stores it in the session bean instances fields and assumes its value is retained for the lifetime of the instance. A developer may use an extended persistent context to store a stateful session bean's persistent conversational state. A session bean that does not make use of Jakarta persistence must explicitly manage cached database data. A session bean instance must write any cached database updates prior to a transaction completion, and it must refresh its copy of any potentially scaled database data at the beginning of the next transaction. A session bean must also refresh any java.sql statement java.sql.statement objects before they are used to a new transaction context. Use of Jakarta persistence provide a session bean with automatic management of data of database data, including the automatic flushing of cache database updates on a transaction commit. The container manages the lifecycle of the session bean instances. It notifies the instances when bean action may be necessary, and it provides a full range of services to ensure that the session bean implementation is scalable and can support a large number of clients. A session bean may be invoked either synchronously or asynchronously. A session bean may be either stateless. A session bean instances contain no conversational state between methods. Any instance can be used for any client. Stateful, a session bean instances contain conversational states which must be retained across methods and transactions. Singleton, a single session bean instance is shared between clients and supports concurrent access. Now we are considering conversational state of a stateful session bean. A developer of a stateful session bean must close and open the resources in the pre-passive and post-passive lifecycle callback interceptor methods. The notation type pre-passive designates a method to receive a callback before a stateful session bean is passivated. Annotation type post-active designates a method to receive a callback after a stateful session bean has been activated. This is in the package jakarta.ejb. The conversational state of a stateful session object is defined as the session bean instance field values, its associated interceptors and their instance field values, plus the transitive closure of the object from these instances fields reached by the following Java object references. To efficiently manage the size of its working set, session bean container may need to temporarily transfer of the state of an ideal stateful session bean instance to some form of secondary storage. The transfer from working set to the secondary storage is called the instance passivation. This transfer is called activation. The advanced case of the session bean's conversational state may contain open resources such as open sockets and open database cursors. A container cannot retain such an open resource when session bean instance is passivated. Developer of a stateful session bean must close and open resources in passivate and post-activate lifecycle callback interceptor method. Container may not only passivate a stateful session bean instance when the instance is not in a transaction. Container must not passivate a stateful session bean that is designated as not passivation capable. A container must not passivate a stateful session bean with an extended persistence context unless the following conditions are met. All the entries in the persistent context are serializable. The entity manager is serializable. The status session bean is never passivated. A singleton session bean is never passivated. Now we are considering the session context interface in protocol between a session bean instance and its container. If the bean specifies a dependency on the session context interface, or if the bean class implements the session bean interface, the container must provide the session bean interface instance with the session context object. The interface session context. The session context interface provides access to the runtime session context that the container provides for a session bean instance. The container passes the session context interface to an instance after the instance has been created. The session context remain associated with the instance for the lifetime of the instance. Jakarta.ejb. This gives a session bean instance access to the instance context maintained by the container. Now we are considering examples in access in the global J&I namespace, this example is session bean exposing a single local business interface. If a foo bean is packaged in foo EJB.jar without a deployment descriptor and deployed as a standalone module, the resulting JNDI names are here. JNDI name entries are here. Here you can see the syntax. Each portable session bean global JNDI names has the following syntax here. The app name only applies if the session bean is packaged within an .ear file. If default to the bean names of the default to the base name of the .ear file with no file name extension unless specified by the application.xml deployment descriptor. Module name is the name of the module in which the session bean is packaged. In a standalone EJB jar file or .war file, module name default to the base name of the module with any file name extension removed. In an EAR file, the module name default to the path name of the module with any file name extension removed but with any directory names included. The default module name can be overridden using the module name element of EJB-jar.xml file for EJB-jar files or web.xml file for .war files. Bean name is the EJB name of the enterprise bean for enterprise beans defined via annotations. It defaults to the unqualified name of the session bean class unless otherwise specified by the name element of the stateless, stateful, or singleton annotation. The enterprise beans defined via the EJB-jar.xml file is specified in the EJB-name deployment descriptor element. Here the container registers a separate JNDI name entry for each local business interface, each remote business interface, any no interface view, any local home interface, and any remote home interface. For the no interface view, last portion of the entry name is fully qualified name of the bean class. In addition to the previous requirement, if the bean exposes only of the applicable client interface, so alternatively has only a no interface view, the container registers an entry for that view with the following syntax. The container is also required to make a session bean JNDI names and available through Java::app and Java::module namespaces. Java::app prefix allows a component executing within a Jakarta E application to access application specific namespaces. The syntax is Java::app, module name, bean name, and a fully qualified interface name. The module name is a required part of the syntax even for name based on a session bean components packaged within the standalone module. The Java::module prefix allows a component executing within the Java EE application to access module specific namespace. The resulting syntax is Java::module, bean name, fully qualified interface name. We are considering an example in return values in asynchronous method here. The annotation type asynchronous used to mark a session bean method as an asynchronous method or to designate all business method of a session bean class as asynchronous. The class async result v wraps the result of an asynchronous method asynchronous method call as a future object, preserving compatibility with the business interface signature. This is in the these are in the package Jakarta.EJB. The bean provider makes the result value of asynchronous invocation available to the client by returning future v object for which both get methods returns the result value. A concrete future v implementation called Jakarta.EJB.async result v is provided by the container as a convenience. The async result v class has a constructor that takes a result value as a parameter. Note that the future v object returned from the bean class method, including an instance of async result v, is only used as a way to pass the result value to the container. This object is not given directly to the caller, since by the definition caller already has a container generated future v object that was returned from the original invocation. Do calculation. Now we are considering missed pre-destroy calls in stateful session beans. The bean provider cannot assume that the container will always invoke the pre-destroy lifecycle callback interceptor method, so EJB removed method for a stateful session bean instance. The bean provider cannot assume that the container will always invoke the pre-destroy lifecycle callback interceptor method, so EJB remove method for the stateful session bean instance. Following scenarios result in the pre-destroy lifecycle callback interceptor methods not being called for an instance. Crash of an enterprise bean container. A system exception thrown from the instances method to the container. A timeout of a client inactivity while the instance is in the passive state. The timeout is specified by the deployer in an enterprise beans container implementation specific way. If resources are allocated in the post construct lifecycle callback interceptor method or EJB create method or in the business method and normally released in a pre-destroy lifecycle callback interceptor method, these resources will not be automatically released in the above scenarios. The application using the stateful session bean should provide some cleanup mechanism to periodically clean up the unrelated resources. For example, if a shopping cart component is implemented as a session bean and the session bean stores the shopping cart content in the database, the application should provide the program that runs periodically removes the abandoned shopping cart from the database. Now we are considering dealing with exceptions in stateless session bean. A runtime exception that is not an application exception thrown from any method of the enterprise bean class, including business methods and the lifecycle callback interceptor methods invoked by the container, results in the transition to the does not exist state. Exception handling is you can check the more information in the documentation about with exception handling. From the client perspective, the session object continues to exist. The client can continue accessing the session object because the container can delegate the client's request to the another instance. Now we are considering singleton session beans initialization in singleton session beans. The following example shows a singleton session bean with the startup logic that initialize its shared state. Annotation type singleton. Component defining annotation for a singleton session bean. This is in the package Jakarta.EJB. By default, the container is responsible for deciding when when to initialize a singleton session bean instance. However, the bean provider can optionally configure the singleton session bean for eager initialization. If the startup annotation appears on the singleton session bean class, or if the singleton session bean has been designated via the deployment descriptor as requiring eager initialization, the container must initialize the single session bean instance during the application startup sequence. The container must initialize all the startup time singleton session beans before any external client request, that is, client requests originating outside of the application, are delivered to an enterprise bean component in the application. The following example shows singleton session bean with startup logic that initializes its shared state. In some cases, explicit initialization ordering dependencies exist between the multiple singleton session bean components in an application. Depends on annotation is used to express these dependencies. A depends on dependency is used in cases where the singleton session bean must be initialized before one or more other singleton session beans. The container ensures that all singleton session beans with which a singleton session bean has a depends on a relationship have been initialized before the post construct method is called. Note that if one singleton session bean merely needs to invocate another singleton session bean from its post construct method, no explicit ordering metadata is required. In that case, the first singleton session bean would merely use an enterprise bean's reference to invoke the target singleton session bean. In this case, the acquisition of the enterprise bean's reference either through injection or lookup does not necessarily imply the actual creation of the corresponding singleton session bean instance. Initialize shared data. Now we are considering session bean class in responsibilities of the bean provider. For example, the client views exposed by a particular session bean are not inherited by a subclass that also happens to define session bean. A session bean class is permitted to have a superclass that are themselves session bean classes. However, there are no special rules that apply to the processing of annotations or deployment descriptor for this case. For the purposes of processing a particular session bean class, all superclass processing is identical regardless of whether the superclasses are themselves session bean classes. In this regard, the use of session bean class as a superclass merely represent a convenient use of implementation inheritance, but does not have component inheritance semantics. For example, the client view exposed by a particular session, a session bean, are not inherited by a subclass that also happens to define the session bean. Assuming foo and bar are local business interfaces and there's no associated deployment descriptor, session bean A exposes a local business interface foo, and the session bean B exposes local business interface bar but not foo. The session bean B need to explicitly include foo in its set of exposed views for the interface to apply, for example. Now we are considering the generation of implementation classes in responsibilities of the container provider. The deployment tools must generate the following classes. Here, the deployment tools provided by the container are responsible for the generation of additional classes when the session bean is deployed. The tools obtain the information that need for generation of the additional classes by introspecting the classes and interfaces provided by the bean provider and by examining the session bean's deployment descriptor. The deployment tools must generate the following classes. A class that implements the session bean's interface, a class that implements the session bean's no interface view, a class that implements session bean's remote home interface, session EJB home class, a class that implements the session bean's remote component interface, session EJB object class, a class that implements the session bean's local home interface, session EJB local home class, a class that implements the session bean's local component interface, session EJB local object class, a class that implements the session bean's web service endpoint, a class that implements the return value of the asynchronous method with return type feature v. The deployment tools may also generate a class that mixes some container specific code with the session bean class. This code may, for example, help the container to manage bean instance at runtime. Tools can use subclassing, delegation, and code generation. The deployment tools may also allow the generation of additional code that wraps the business methods and is used to customize the business logic to an existing operational environment. For example, a wrapper for a debit function on the account manager bean may check that the debited amount does not exceed a certain limit. Now we are considering session synchronization. Jakarta.ejb.session synchronization interface in enterprise beans using container managed transaction demarcation in support for transaction. A stateful session bean with the container managed transaction demarcation can optionally implement the Jakarta.ejb.session synchronization interface or use the session synchronization annotations. Interface session synchronization. The session synchronization interface allows stateful session beans instance to be notified by its container of the transaction boundaries. This is in the package jakarta.ejb. Now we are considering a session bean, session synchronization callbacks in container managed transaction demarcation for session beans. If a session bean class implements the Jakarta.ejb.session synchronization interface or uses session synchronization annotations, the container must invoke after begin, before completion, and after completion callbacks on the instance as part of the transaction commit protocol. Void after begin. The after begin method notifies the stateful session bean instance that a new transaction has started and that subsequent business methods on the instance will be invoked in the context of the transaction. Void after completion, boolean committed. The after completion method notifies the stateful bean instance that the transaction commit protocol has completed and tells the instance whether the transaction has been committed or rollback. Void before completion. The before completion method notifies the stateful session bean instance that the transaction is about to be committed. These are in the interface session synchronization, which is in the package jakarta.ejb. If a stateful session beans post-construct, pre-destroy, and pre-perceive or post-activate lifecycle callback interceptor methods are invoked in the scope of a transaction, session synchronization callbacks for such transactions are not called on the bean instance. The container invokes after begin method on an instance before it invokes the first business method in the transaction. The container invokes the before completion method to give the enterprise bean instance last chance to cause the transaction to rollback. The instance may cause the transaction to rollback by invoking EJB context.setRollbackOnly method. The container invokes the after completion boolean committed method after the completion of the transaction commit protocol to notify the enterprise bean instance of the transaction outcome. Now we are considering all other exceptions in bean method runs in the context of a transaction that container started immediately before dispatching the business method in exceptions from the session beans business interface methods and no interface view methods in container provider responsibilities in exception handling. The class EJB exception. The EJB exception is thrown to report that the invoked business method or callback method could not be completed because of an unexpected error. For example, the instance failed to open a database connection. This is in the package jakarta.ejb. The container's actions are log in the exception or error, roll back the container started transaction, discard instance, throw EJB exception to client. Now we are considering containers actions in all other exceptions in this bean method runs in the context of a transaction that container started immediately before dispatching the business method. This case may happen with the required new attributes in method condition in exceptions from method invoke via session beans 2.1 client view or through web service client view. This containers actions are here: log the exception or error, roll back the container started transaction, discard the instance, throw remote exception to remote or web service client, throw EJB exception to local client. Now we are considering non-existing stateful session object. If a client makes a call to a stateful session bean object that has been removed, the container should throw the jakarta.ejb.nosuch EJB exception. The class nosuch EJB exception. No such EJB exception is thrown if an attempt is made to invoke a business method on a stateful session or singleton object that no longer exists. This is in the package jakarta.ejb. If the enterprise bean 2.1 client view is used, the container should throw the java.rmi.nosuch object exception, which is a subclass of java.rmi.remote exception to a remote client, or the jakarta.ejb.nosuch object local exception to the local client. Now we are considering default stateful session bean concurrency behavior, incompatibility and migration. This means by default the client will not receive the jakarta.ejb.concurrent access exception when concurrent access occurs for a request. The class concurrent access exception. A concurrent access exception indicate that the client has attempted an invocation on a stateful session bean or singleton bean while other invocation is progress and such concurrent access is not allowed. This is in the package jakarta.ejb. Prior versions of the enterprise bean specification allows containers to choose default behavior in the event of concurrent access attempt to a stateful session bean instance. This specification requires a default of serialized request in the face of concurrency. This means by default client will not receive jakarta.ejb.concurrent access exception when concurrent access exception occurs for a request. This should have a minimal impact to concurrent correctly written application, since even with the prior behavior there was no guarantee of receiving such an exception due to the inherent race conditions. Application wishing to receive an exception in the face of concurrency can request that behavior through newly defined metadata. Now we are considering adapting enterprise beans 3.x session beans to earlier client views. When the client is deployed, the container classes that implement the enterprise beans 2.1 home and remote component interfaces or local home or local component interfaces referenced by the client must provide the implementation of the jakarta.ejb home and the jakarta.ejb object interfaces, or the jakarta.ejb local home and jakarta.ejb local object interfaces respectively. Interface EJB home. the EJB interface must be extended by all Enterprise Beans remote home interfaces, and Enterprise Beans remote home interface defines the methods that allow a remote client to create, find, and remove Enterprise Bean objects. Interface EJB object. The EJB object interface is extended by all Enterprise Beans remote interfaces, and Enterprise Beans remote interface provides the remote client view of an Enterprise Bean object. The Enterprise Beans remote interface defines the object methods callable by a remote client. Interface EJB local home. The EJB local home interface must be extended by all Enterprise Beans local home interfaces. An Enterprise Beans local home interface defines the method that allow local clients to create, find, and remove Enterprise Beans objects. Interface EJB local object. The EJB local object interface must be extended by all Enterprise Beans local interfaces. An Enterprise Beans local interface provides the local client view of an Enterprise Bean object. An Enterprise Beans local interface defines the business methods callable by local clients. These are in package Jakarta.ejb. Clients return to Enterprise Bean 2.1. An earlier client view depends on the existence of the home of a home and component interface. Session Bean written to Enterprise Bean 3.x API may be adapted to such earlier pre-existing client views interfaces. The Session Bean designate the interface to be adapted by using remote home and local home metadata annotations on the Bean class or equivalent deployment descriptor elements. The corresponding remote and local component interfaces are not explicitly specified when using these annotations. Rather, they are derived from home and local home interfaces respectively. When the client is deployed, the container classes that implement the Enterprise Bean 2.1 home and remote component interfaces or local home and local component interfaces referenced by the client must provide the implementation of jakarta.ejb.home and jakarta.ejb.ejb home EJB object interfaces, or the jakarta.ejb.ejb local home and jakarta.ejb.ejb local object interfaces respectively. In addition, the container implementation classes must implement the method of the home and component interfaces to apply the Enterprise Bean 3.x component being referenced as now we are considering Session Bean references in looking up Session Bean references in bootstrapping API in embeddable usage. The following example illustrates the lookup of full local business interface of a Session Bean with EJB name foo bean in the EJB -jar foo.jar. The public abstract context get context retrieve a naming context for a lookup references to a Session Bean executing an embeddable container. The class EJB container used to execute an Enterprise Bean application in an embeddable container. These are in the package jakarta.ejb.embeddable. The EJB container instance can be used to retrieve a javax naming.context object that supports the lookup of the client references to Session Beans running within an embedded container. Session Bean references are identified using portable java.global JNDI name syntax. Client retrieves a context objects using the EJB container method. The following example illustrate the lookup of a full local business interface of a Session Bean with the EJB name foo bean in the EJB -jar.foo.jar. Now we are considering pre-perceive. Now we are considering entity object life cycle in client view of an entity bean. References to the entity object and stateful session bean instance. Basically, here we are now considering references to entity object and stateful session bean instance specification and conversational state. Here, the if an entity bean is referenced from a stateful session bean, the bean provider is required to ensure that the pre-passive method leaves the instance field ready to be serialized by the container. The annotation type pre-passive designate the method to receive the callback before a stateful session bean is passivated. This is in the package jakarta.ejb. An entity bean is referenced in addition to the rules described in the enterprise beans core contracts and requirement document, subsection instance specification and conversational state for the entity bean references, the object that are assigned to the instance such non-transient field after the session bean pre-passive method completes also be one of the following: a reference to an entity bean local component interface even if it is non-serializable, a reference to an entity bean's local home interface if it is even if it is not serializable. javax.ejb exception, javax.ejb.create exception could not create stateless EJB. This error occurred under NetBeans 6.9 and Glassfish 3. As an error example 2, we can consider this one, EJB 5128. The Sun Java System Communications Application Server 1.0 error message EJB 5128. A problem occurred while the container was activating a stateful session bean. One possible cause is that the bean code threw a system exception from its EJB activate method. Solution is to check the stack trace to see whether the exception was thrown from the EJB activate method, and if so, double check the application code to determine what caused the exception. Now we are focusing on EJB. Enterprise Java Beans technology is the server-side component architecture for Java Platform Enterprise Edition Java EE. EJB technology enables rapid and simplified deployment of distributed, transactional, secure, and portable applications based on Java technology. Here you can see a typical EJB architecture. An EJB object consists of a number of different objects. First one, bean itself, which must be written completely by the application programmer. Number 2 here, home object, which is responsible for creation and removal of a bean. This is automatically generated from an interface specification given by the application programmer. And EJB object, which acts as an RMI remote object visible to the client. It automatically generated from an interface specification given by the application programmer. A client to the EJB, which is written by the application programmer. The bean, home object, and the EJB object will all be embedded in an EJB container, which is run from an EJB server. These are supplied by the EJB vendor and are not the direct concern of the application programmer. Here you can see a client is connected to home and EJB object. Remote call is passed from client to home. Remote call is passed from client to EJB object. Home is connected to bean. Local call is passed from home to bean. EJB object is connected to bean. Local call is passed from EJB to objects to bean. Here you can see a life cycle of EJB 2.1 entity bean with container managed persistence. An entity bean is an EJB 2.1 enterprise bean component that manages persistent data, performs complex business logic, potentially uses several dependent Java objects, and can be uniquely identified by a primary key. This figure shows the EJB 2.1 CMP entity bean life cycle. There are three states: does not exist, pooled, and ready. To transition from does not exist state to the pooled state, the following occurs. New instant method is invoked and the set entity context method is invoked with the entity context argument, while the pool state EJB home, EJB find, and EJB select methods may be invoked. To transition from the pool state to the ready state, following occurs for a new instance. The EJB create method is invoked and the EJB post create method is invoked, while in the ready state, the following state to the pooled following methods may be invoked: EJB load, business methods, EJB timeout, EJB select, and EJB store. To transition from the ready method to the pooled state, the container select the entity bean as eligible for passivation and then invokes the EJB passivate method. To transition from the pooled state to the ready state, the following occurs for the previously passivated entity bean. The EJB activate method is invoked. The transition from the ready state to the pooled the following occurs for a removed entity bean. The EJB removed method is invoked. To transition from the pooled state to the does not exist state, unset entity context method is invoked. The EJB 2.1 enterprise beans lifecycle methods, as specified in the javax.egb entity bean interface, that an entity bean with container managed persistent must implement. For EJB 2.1 entity beans with container managed persistence, you must at least provide an empty implementation for all callback methods. EJB create method, you must implement an EJB create method corresponding to each create method declared in the home interface. When the client invokes the create method, the container first invokes the constructor to instantiate the object, then it invokes the corresponding EJB create method. For an entity bean with container managed persistent, use this method to initialize container managed persistent fields. The return type of all EJB create methods is the type of the bean's primary key. Optionally, you can initialize the bean with the unique primary key and return it. If you rely on container to create and initialize the primary key, return null. EJB post create, the container invokes this method after the environment is set. For each EJB create method, the EJB post create method must exist with this argument. For an entity bean with container managed persistent, you can leave this implementation empty or use your implementation to initialize parameters within or from entity context. EJB remove method, the container invokes this method before it ends the life cycle of the entity bean. For an entity bean with container managed persistent, you can leave this implementation empty or use your implementation to perform any required cleanup, for example, closing external resources such as field handles. EJB store method. This container invokes the container invokes this method right before the transaction commits. It saves the persistent data to an outside resource such as database. For an entity bean with container managed persistent, you can leave this implementation empty. EJB load method. This container invokes this method. The container invokes this method when the data should be reinitialized from the database. This normally occurs after activation of an entity bean. For an entity bean with container managed persistent, you can leave this implementation empty. EJB activate, the container calls this method directly before it activates an object that was previously passivated. Perform any necessary reacquisition of resources in this method. EJB passivate, the container calls this method before it passivates the object. Release any resources that can be easily recreated in EJB activate and save storage space. Typically, you want to release resources that cannot be passivated, such as sockets or database connections. Retrieve these resources in the EJB activate method. Here, does not exist interacts with pooled. new instance, then set entity context are passed from does not exist to pool. EJB home is passed from pool to pool, and EJB find, then EJB select are passed from pool to pool. Pooled interacts with ready. EJB create, then EJB post create are passed from pool to ready. EJB loads are passed from ready to ready. Business methods are passed from ready to ready. EJB timeout are passed from ready to ready. EJB select is passed from ready to ready. EJB store is passed from ready to ready. EJB activate is passed from pool to ready. EJB passivate is passed from ready to pool. EJB removed is passed from ready to pool. Unset entity context is passed from pool to does not exist. Here you can see a life cycle of a message driven bean. The EJB container usually creates a pool of message driven bean instances. For each instance, EJB container performs these checks. First, if the message driven bean uses dependency injection, the container injects these references before instantiating the instance. 2. The container calls the method annotated at post construct, if any. Like a stateless session bean, a message driven bean is never passivated, and it has only two states, non-existent and ready to receive messages. At the end of the life cycle, the container calls the method annotated at pre-destroy, if any. The bean instance is then ready to garbage collection. Here you can see does not exist and ready. Dependency injection, if any, then post construct callback, if any, is passed from does not exist to ready. On message is passed from ready to ready. Pre-destroy callback, if any, is passed from ready to does not exist. Message driven beans here you can see messaging with MDBs in JMS Java EE programming. Message driven beans is one of family of enterprise Java beans. EJB components described in the EJB 2.0 and later specification. Message driven beans provide asynchronous messaging. Other EJB components, session beans and entity beans, can only be called synchronously through a standard EJB interface. However, enterprise applications often need asynchronous messaging to allow server-side components to communicate without tying up server resources. Any application whose server-side component must respond to application events need an EJB component that can receive and consume messages without being tightly coupled to the message producer. In enterprise application, this capability must also scale under increased load. Message-driven beans (MDB) is an EJB component supported by a specialized EJB container. That provide distributed services for component it supports. The MDB implements the JMS message listener interface, the onMessage method written by the MDB developer is invoked when MDB container receives the message. OnMessage method consumes the message just as the onMessage method of the standard message listener object would. You do not remotely invoke methods on MDBs as you do on other EJB components. Therefore, no home or remote interface associated with them. Each MDB can consume messages from only single destination. The message can be produced by standalone JMS applications or JMS components or EJB components. As shown in this figure. Specialized EJB container supports the MDB. This MDB container creates instance of MDB and set them for asynchronous consumption of messages. The container set up a connection with the broker, including authentication, creates a pool of sessions associated with the given destinations, and messages are and manages the distribution of messages among pool sessions. Since the container controls the lifecycle of MDB instances, it manages the pool of MDB instances to accommodate incoming message loads. Associated with each MDB is a deployment descriptor that specified the connection factory attributes and destination properties that the container uses in setting up message consumption. The deployment descriptor can also include other information needed by deployment tools to configure the container. Each such container supports all instances of a single MDB. Here you can see a JMS message produces a JMS component or application, and this is connected to destination. EJB container is connected to destination. EJB instance is in EJB container. Here you can see JMS message service. Broker and destinations are inside JMS message service. Destinations are connected to MDB container. JMS message consumers, MDB instance is inside MDB container. It has MDB instance has onMessage method. As an example, here you can see the client view of a message-driven beans deployed in a container. To a client, a message-driven bean is simply a message consumer. The client sends the messages to the destination or endpoint, for which the message-driven bean is the message listener, just as it would do any other destination or endpoint. The message-driven bean, as a message consumer, handles the processing of the message. From the perspective of the client, existence the existence of the message-driven bean is completely hidden behind the destination or endpoint for which the message-driven bean is the message listener. This diagram illustrates the view that is provided to a message-driven beans clients. Clients JNDI namespace may be configured to include the destinations or endpoints of the message-driven beans installed in multiple enterprise beans containers located on multiple machines on the network. Actual locations of enterprise bean and enterprise beans container are in general transparent to the client using the enterprise bean. References to message destination can be injected or they can be looked up in the client's JNDI namespace. Here you can see client is connected to destination or endpoint. Here you can see message-driven bean instances are inside message-driven bean and message-driven bean is inside container. Here you can see message-driven bean is connected is message-driven. Sorry, here the destination or endpoint interacts with the container message-driven bean here. Here you can see life cycle of a message-driven bean. When a client sends a message to a destination for which a message-driven bean is the consumer, the container selects one of its method ready instances and invokes the instance's message listener method. The following figure illustrates the lifecycle of a message-driven bean instance. The following steps describe the lifecycle of a message-driven bean instance. A message-driven bean instance lifecycle starts when the container invokes the message-driven bean class constructor or create a new instance. Next, the container injects the bean's message-driven context object if applicable and performs any other dependency injection as is specified by the metadata annotations on the bean class or by deployment descriptor. Container then calls the bean's post-construct lifecycle callback methods, if any. Message-driven bean instance is now ready to be delivered a message sent to its associated destination or endpoint by any client or a call from the container to a timeout callback method. When the container no longer needs the instance, which usually happens when the container wants to reduce the number of instances in a method ready pool, the container invokes the pre-destroy lifecycle callback methods for it, if any. This ends the lifecycle of the message-driven bean instance. Here you can see a message here does not exist interact with the message ready pool. Here does not exist is connected to method ready pool via step 1 around construct callback, if any. Step 2 constructor. Step 3 dependency injection, if any. Step 4 post construct callback, if any. Here message method ready pool is connected to method ready pool itself via message listener method. Here action resulting from client message arrival. Here message ready pool is connected to itself via timeout callback method, action initiated by the container. Here method ready pool is connected to does not exist via pre-destroy callbacks, if any. Now we are considering transaction diamond scenario with entity object. An entity object may be accessed by multiple clients in the same transactions. For example, a program A may start a transaction, a call program B and program C in the transaction context, and then commit the transaction. If program B and C access the same entity object, the topology of the transaction creates the diamond. An example not realistic in practice is a client program that tries to perform 2 purchases at different stores within the same transaction. At each store, the program that is processing the client's purchase request debits the client's bank account. It is difficult to implement an enterprise bean server that handles the case in which program B and C access an entity object through different network paths. This case is challenging because many enterprise bean servers implement the enterprise beans container as a collection of multiple processes running on the same or multiple machines. Each client is typically connected to a single process. If clients B and C connect to different enterprise bean container processes, and both B and C needs to access the same object in the same transaction, the issue is how the container can make it possible for B and C to see a consistent state of the entity object with the same transaction. The above in this example here illustrate a simple diamond. We use term diamond to refer to any distributed transaction scenario in which an entity object is accessing the same transaction through multiple network paths. Note that the diamond scenario, the client B and C access the entity object serially. Concurrent access to an entity object in the same transaction context would be considered an application programming error, and it would be handled by a container specific way. Note that the issue of handling diamond is not unique to the enterprise beans architecture. This issue exists in all distributed transaction processing systems. Here you can see a program A is connected to program B via TX1. Here program A is connected to program C via TX1. Program B is connected to TX entity object via TX1, and program C is connected to entity object via TX1, and entity object is inside the enterprise bean container. Here you can see the client view of entity beans deployed in a container. This diagram illustrates the view that a container provides to client of the entity beans deployed in the container. Note that a client may be a local client of some entity beans and remote client of others. Here the interface EJB object. The EJB object interface is extended by all enterprise beans remote interfaces. An enterprise beans remote interface provide the remote client view of an enterprise bean object. An enterprise beans remote interface defines the business methods callable by a remote client. EJB interface EJB home. The EJB home interface must be extended by all Enterprise Beans remote home interfaces. An Enterprise Beans remote home interface defines the method that allows a remote client to create, find, and remove Enterprise Bean objects. Interface EJB local object. The EJB local object interface must be extended by all Enterprise Beans local interfaces. An Enterprise Beans local interface provides the local view of an Enterprise Bean object. An Enterprise Beans local interface defines the business method callable by local clients. Interface EJB local home. The EJB local home interface must be extended by all Enterprise Beans local home interfaces. An Enterprise Beans local home interface defines the methods that allow local clients to create, find, and remove Enterprise Bean objects. Here you can see client is connected to EJB objects, and EJB home here entity in with entity bean 1. Here client is connected to EJB local objects and EJB local home. Here EJB objects and EJB home interacts with container and entity bean 1 here. Here EJB local objects and EJB local home interacts with container and entity bean 2 here. Here entity bean 1 and entity bean 2 and other enterprise beans are inside the container. Here you can see client view of entity object lifecycle. This diagram illustrates a client point of view of an entity object lifecycle. The term referenced in this diagram means that the client program has a reference to through the entity object remote or local interface. The entity object does not exist until it is created. Until it is created, it has no identity. After it is created, it has identity. A client creates an entity object using entity beans home interface, whose class is implemented by the container. When a client creates an entity object, the class obtains a reference to the newly created. The client object obtains a reference to the newly created entity object. And in an environment with legacy data, entity objects may exist before the container and entity beans are deployed. In addition, an entity object may be created in the environment via a mechanism other than by invoking create method of the home interface, for example by inserting a database record. But it still may be accessed via a finder methods. Also, an entity object may be deleted directly using other means than the remove operation. For example, by deletion of the database record. The direct insert and direct delete transitions in this diagram represent such a direct database manipulation. All entity objects are considered persistent object. The lifetime of an entity object is not limited by the lifetime of the Java virtual machine process in which the entity instance executes. While a crash of the Java virtual machine may result a rollback of the current transaction, It does not destroy previously created entity objects nor invalidate the references to the home and component interface held by the clients. Multiple clients can access the same entity object concurrently. Transactions are used to isolate the client work from each other. The references to the entity object remote interfaces. The client can get the reference to an existing entity object's remote interface in any of the following ways. Receive the reference as a parameter in a method call input parameter or result. Find the entity object using finder method defined in the here you can see the client view of a message driven beans deployed in a container. To a client, a message driven bean is simply a message consumer. The client sends the messages to the destination or endpoint, for which the message driven bean is the message listener, just as it would do any other destination or endpoint. The message driven bean as a message consumer handles the processing of the message. From the perspective of the client, the existence of the message driven bean is completely hidden behind the destination or endpoint, for which the message driven bean is the message listener. The diagram illustrates the view that is provided to a message driven beans clients. Client's JNDI namespace may be configured to include the destinations or endpoints of the message driven beans installed in multiple enterprise beans containers located on multiple machines on a network. Actual locations of enterprise bean and enterprise beans container are in general transparent to the client using the enterprise bean. References to message destination can be injected, or they can be looked up in the client's JNDI namespace. Here you can see client is connected to destination or endpoint. Here you can see message driven bean instances are inside message driven bean, and message driven bean is inside container. Here you can see message driven bean is message driven. Sorry, here the destination or endpoint interacts with the container message driven bean. Here you can see life cycle of a message driven bean. When a client sends a message to a destination for which a message driven bean is the consumer, the container selects one of its method ready instances and invokes the instance's message listener method. The following figure illustrates the life cycle of a message driven bean instance. The following steps describe the life cycle of a message driven bean instance. A message driven bean instance life cycle starts when the container invokes the message driven bean class constructor or create a new instance. Next, the container injects the bean's message driven context object if applicable, and performs any other dependency injection as is specified by the metadata annotations on the bean class or by deployment descriptor. Container then calls the bean's post construct lifecycle callback methods, if any. Message driven bean instance is now ready to be delivered a message sent to its associated destination or endpoint by any client, or a call from the container to a timeout callback method. When the container no longer needs the instance, which usually happens when the container wants to reduce the number of instances in a method ready pool, the container invokes the pre-destroy lifecycle callback methods for it, if any. This ends the lifecycle of the message-driven bean instance. Here you can see a message here does not exist interact with the message ready pool. Here does not exist is connected to method ready pool via step 1 around construct callback, if any, step 2 constructor, step 3 dependency injection, if any, step 4 post construct callback, if any. Here message method ready pool is connected to method ready pool itself via message listener method. Here action resulting from client message arrival. Here message ready pool is connected to itself via timeout callback method, action initiated by the container. Here method ready pool is connected to does not exist via pre-destroy callbacks, if any. Now we are considering transaction diamond scenario with entity object. An entity object may be accessed by multiple clients in the same transactions. For example, a program A may start a transaction, a call program B and program C in the transaction context, and then commit the transaction. If program B and C access the same entity object, the topology of the transaction creates the diamond. An example not realistic in practice is a client program that tries to perform 2 purchases at different stores within the same transaction. At each store, the program that is processing the client's purchase request debits the client's bank account. It is difficult to implement an enterprise bean server that handles the case in which program B and C access an entity object through different network paths. This case is challenging because many enterprise bean servers implement the enterprise beans container as a collection of multiple processes running on the same or multiple machines. Each client is typically connected to a single process. If clients B and C connect to different enterprise bean container processes, and both B and C needs to access the same object in the same transaction, the issue is how the container can make it possible for B and C to see a consistent state of the entity object with the same transaction. The above in this example here illustrate a simple diamond. We use term diamond to refer to any distributed transaction scenario in which an entity object is accessing the same transaction through multiple network paths. Note that the diamond scenario, the client B and C access the entity object serially. Concurrent access to an entity object in the same transaction context would be considered an application programming error, and it would be handled by a container specific way. Note that the issue of handling diamond is not unique to the enterprise beans architecture. This issue exists in all distributed transaction processing systems. Here you can see a program A is connected to program B via TX1. Here program A is connected to program C via TX1. Program B is connected to TX entity object via TX1, and program C is connected to entity object via tx1, and entity object is inside the enterprise bean container. Here you can see the client view of entity beans deployed in a container. This diagram illustrates the view that a container provides to client of the entity beans deployed in the container. Note that a client may be a local client of some entity beans and remote client of others. Here the interface EJB object. The EJB object interface is extended by all enterprise beans remote interfaces. An enterprise beans remote interface provide the remote client view of an enterprise bean object. An enterprise beans remote interface defines the business methods callable by a remote client. EJB interface EJB home. The EJB home interface must be extended by all enterprise beans remote home interfaces. An enterprise beans remote home interface defines the method that allows a remote client to create, find, and remove enterprise bean objects. Interface EJB local object. The EJB local object interface must be extended by all enterprise beans local interfaces. An enterprise beans local interface provides the local view of an enterprise bean object. An enterprise beans local interface defines the business method callable by local clients. Interface EJB local home. The EJB local home interface must be extended by all enterprise beans local home interfaces. An enterprise beans local home interface defines the methods that allow local clients to create, find, and remove enterprise bean objects. Here you can see client is connected to EJB objects, and EJB home here entity in with entity bean 1. Here client is connected to EJB local objects and EJB local home. Here EJB objects and EJB home interacts with container and EJB bean 1 here. Here EJB local objects and EJB local home interacts with container and entity bean 2 here. Here entity bean 1 and entity bean 2 and other enterprise beans are inside the container. Here you can see client view of an entity object lifecycle. This diagram illustrates a client point of view of an entity object lifecycle. The term referenced in the diagram means that the client program has a reference to an entity object remote or local interface. An entity object does not exist until it is created. Until it is created, it has no identity. After it is created, it has an identity. A client creates an entity object using the entity beans home interface, whose class is implemented by the container. When a client creates an entity object, the client obtains a reference to the newly created entity object. In an environment with legacy data, entity object may exist before the container and entity bean are deployed. In addition to an entity object may be created within the environment via the mechanism other than the invoking the create method of the home interface. For example, by inserting database record, but still need to be accessed via the find methods. Also, the entity object may be deleted directly using other means other than remove operation. For example, by deletion from a database, deletion of a database record, the direct insert and the direct delete transitions in the diagram represent the such direct database manipulation. All entity objects are considered persistent object. The lifetime of an entity object is not limited by the lifetime of the Java virtual machine process in which the entity bean instance executes. While a crash of the Java virtual machine may result a rollback of current transactions, it does not destroy previously created entity objects nor invalidate the references to the home and component interfaces held by clients. Multiple clients can access the same entity object concurrently. Transactions are used to isolate the client's work from each other. References to entity object remote interfaces. A client can get a reference to an existing entity object's remote interface in any of the following ways. Receive a reference as a parameter in a method call, input parameter or result. Find the entity object using the finder method defined in the entity beans remote home interface. Obtain a reference from entity beans handle. A client that has a reference to an entity object's remote interface can do any of the following: invoking business method on entity objects through the remote interface, obtaining reference to the enterprise beans remote home interface, pass a reference as a parameter or return value of a method, obtain an entity object's primary key, obtain entity object's handle, remove the entity objects. All references to an entity object that does not exist are invalid. All attempted invocation on entity object that does not exist result in Java java.rmi.no such object no such object exception being thrown. References to entity object local interfaces. A local can get reference to an existing entity object's local interface in any of the following ways: receive the reference as a result of a method call, find the entity object using finder method defined in the entity beans local home interface, invoke a local client that has a reference to an entity object's local interface can do any of the following: invoke business method on the entity object through the local interface, obtain reference to an enterprise beans local home interface, pass the reference as a parameter or return a value of a local method call, obtain the entity object's primary key, remove the entity object. All local reference to an entity object that does not exist are invalid. All attempted invocations on entity object that does not exist result in a Jakarta.EJB.no such object local exception being thrown. A local interface must not be passed as an argument or result of a remote interface method. References to entity objects and stateful bean instance passivation and conversational state. If an entity bean is referenced from a stateful session bean, the bean provider is required to ensure the pre-perceived methods lives in the instance field ready to be initialized by the container. In addition to the rules described in the enterprise beans core contracts and requirement document section, instance passive and conversational state for the entity bean references, the object are assigned to the instance as a non-transient field after the session being pre-perceived method completes can also be one of the following: a reference to an entity bean's local component interface, even if it is not serialized; a reference to an entity bean's local home interface, if it is not serializable. Here you can see the client view of the entity object life cycle. Here you can see does not exist and not reference. It is connected. It's connected to exist and referenced via home.create method. Create action initiated by client. Here you can see does not exist and not reference is connected to exist and not reference via direct insert, and exist and not referenced is connected to exist and reference via home.find method. And here you can see exist and reference is connected to itself via object.business method. Here you can see exist and not reference is connected to itself via home.business method. Exist and reference is connected to does not exist and referenced via object.remove method or object.home.remove method or direct delete. And here does not exist and reference is connected to itself via object.business method, throws no such object exception or no such local object exception. Does not exist and reference is connected to does not exist and not reference via release reference. Here does not exist and reference is connected to exist and not reference via release reference. Exist and not reference is connected to does not exist and not referenced via direct delete or home.remove method. Here direct delete action on database from outside enterprise beans. Here you can see a view of underlying data sources accessed through entity beans. The enterprise beans component model provides a separation between client view of a bean as presented by its home and component interfaces and the entity bean class, which provides implementation of the client view. The enterprise beans architecture for container managed persistent adds to this separation between entity bean class as defined by the bean provider and its persistent representation. The container managed persistent architecture thus provides not only a layer of data independence between client view of beans and as an entity bean and the bean provider internal view of the bean in terms of an entity bean instance, but also between the entity bean instance and its persistence representation. This allows an entity bean to be evolved independently from its client without requiring the redefinition or recompilation of these clients, and it allows an entity bean to be redeployed across different containers and different persistent data stores without requiring the redefinition or recompilation of entity bean class. In a container managed persistent, unlike in bean managed persistence, The bean provider does not write database access calls in the methods of the entity bean class. Instead, persistence is handled by the container at runtime. The entity bean provider must specify in the deployment descriptor those persistent field and relationship for which the container must handle data access. The bean provider codes all persistent data access by using the accessor methods that are defined for the abstract persistence schema. The implementation of the persistent field and relationships as well as all data access is deferred to the container. It is the responsibility of the deployer to map the abstract persistent schema of a set of interrelated entity bean classes into physical schema used by the underlying data store. For example, into a relational schema by using the containers providers tools. The deployer uses the deployment descriptor as the input to the container providers tools to perform this mapping. The container providers tools are also used to generate the concrete implementation of the entity bean classes, including the code that delegate calls to the accessor methods of the entity bean class to the runtime persistent data access layer of the container. The enterprise beans deployment descriptor for entity bean 2.1. Entity beans describe logical relationships among entity beans. It does not provide a mechanism for specifying how the abstract persistent schema of an entity bean or of a set of interrelated entity beans is to be mapped to underlying database. This is the responsibility of the deployer, who using the container provider tools uses logical relationships that are specified in the deployment descriptor to map the physical relationships that are specific to underlying resource. It is the responsibility of the container to manage the mapping between the logical and physical relationships at runtime and to manage the referential integrity of the relationships. The advantage of using container managed persistent is that the entity bean can be logically independent of the data source in which the entity is stored. The container providers tools can, for example, generate classes that use JDBC or SQLJ to access entity state in a relational database, classes that implement access to non-relational data source such as an IMS database, or classes that implement function calls to existing enterprise applications. These tools are typically specific to data source. Here you can see entity bean is an object view of the collection of related records in the database. Here the entity bean is an object view of the existing application. Here you can see client is connected to odd entity bean, which is in the container. Odd entity bean is connected to here order 100 here connected to the database. Order 100 is in the database here. Client is connected to odd entity bean. Odd entity bean is in the container here. Odd entity bean is connected to existing application. Existing application is connected to data source here, and order 100 is inside the database here. Here you can see a relationship example. Relationship example illustrate an order entity bean with relationship to line items and customers, which are other entity beans within the same local scope. Product is indirectly related to order by means of the relationship between line item and product. So here you can see the order bean here. Order bean is has a one order bean can have one customer here. This order beans and customer interacts with the order customer here, and one customer can have many order beans. Order bean is aggregated with line items through via order line item. One order bean can have many line items. One line item can have one order bean. One line item is interacts with the product through product line item. So one line item in this relationship, one line item can have one product, and one product can have many line items. Here you can see a overview of the entity bean runtime execution model. The subscreen describes the runtime model and the classes used in the description of the contract between an entity bean and its container. This shows an overview of the runtime model. The client of an entity bean may be a client or maybe a local client, or it may be a remote client. An enterprise bean is an object whose class is provided by the bean provider. The class of the entity bean with container managed persistent is abstract. The concrete bean class is generated by the containers providers tools at the deployment time. The container is also responsible for providing the implementation of the java.util.collection classes that are used in the maintaining the container managed relationships of the entity bean. An entity EJB object or EJB local object is an object whose class was generated at the deployment time by the container providers tools. A client never references an entity bean instance directly. A client always references an entity bean and an entity EJB object or EJB local object whose class is generated by the container provider tools. The entity object class implements an entity bean's remote interface. The entity local object class implements an entity bean's local interface. A related entity bean never references another entity bean instance directly. A related entity bean, like any other local client of an entity bean, always references an entity EJB local object whose class is generated by the container providers tools. An entity EJB home or EJB local home object provides lifecycle operations, create, find, remove for its entity object, as well as home business methods, which are business methods that are not specific to an entity bean instance. The class for the entity EJB home or EJB local home object is generated by the container providers tools at runtime, tools at deployment time. An entity EJB home or EJB local home object implements entity bean's remote or local home interface that was defined by the bean provider. Here, interface EJB object. The EJB object interface is extended by all enterprise beans remote interfaces. An enterprise bean's remote interface provides the remote client view of an enterprise bean object. An enterprise bean's remote interface defines the business methods callable by remote client. Interface EJB home. The EJB home interface must be extended by all enterprise beans remote home interfaces. An enterprise beans remote home interface defines the methods that allow a remote client to create, find and remove enterprise bean objects. Interface EJB local home object. EJB local object interface must be extended by all the enterprise beans local interfaces. An enterprise beans local interface provides the local client view of an enterprise bean object. An enterprise beans local interface defines the business methods callable by local clients. The interface EJB local home. The EJB local home interface must be extended by all enterprise beans local home interfaces. An enterprise beans local home interface defines the method that allow local clients to create, find, and remove enterprise bean objects. Here you can see a client is connected to EJB object and EJB home. Here EJB objects and EJB home interacts with the container and enterprise bean here, and EJB objects and EJB home are connected to enterprise bean instances here. Here the client is connected to EJB local home, EJB local objects and EJB local home. EJB local objects and EJB local home interacts with container and enterprise bean 2 here. EJB local objects and EJB local home are connected to enterprise bean instances here. Here the enterprise bean is assigned in enterprise bean 1 and enterprise bean is assigned in enterprise bean 2. Here the this section enterprise bean 1 and enterprise bean 2 are in the container. Here this section EJB object, EJB home, EJB local object, EJB local home are container provided classes, and here the enterprise bean instances. Here are classes and this in this section classes provided by bean provider and container here. Here you can see the life cycle of an entity bean instance. An entity bean instance is in one of the following 3 states. It does not exist. Pooled state. An instance in the pooled state is not associated with any particular entity bean identity. Ready state. An instance in the ready state is assigned an entity object identity. The following steps describe the life cycle of an entity bean instance. An entity bean instance life starts when the container creates the instance using new instance. The container then invokes the set entity context method to pass the instance a reference to the entity context interface. And the entity context interface allows the instance to invoke services provided by the container and to obtain the information about the caller of a client invoked method. And the instance enters the pool of available instances. Each entity bean has its own pool. While the instance is in the available pool, the instance is not associated with any particular entity bean object identity. All instances in the pool are considered equivalent, and therefore any instance can be assigned by the container to any entity object identity at the transition to the ready state. While the instance is in the pool state, the container may use the instance to execute any of the entity beans finder method shown as EJB find method in the diagram here, or any of the entity beans home method shown in the EJB home method in the diagram here. The instance does not move to the ready state during the execution of the finder or home method. An EJB select method may be called by an entity beans home method while the instance is in the pooled state, and the instance transitions from pooled state to the ready state when the container select that instance to service a client call to an entity object or an EJB timeout. Timeout method. There are 2 possible transitions from the pooled to the pool to the ready state through EJB create method and EJB post create methods, or through the EJB activate method. The container invokes the EJB create method and EJB post create methods when the instance is assigned to an entity object during the entity bean entity object creation. That is, when the client invokes a create method on entity bean's home object. The container invokes the EJB activate method on an instance when the instance need to be activated to the service an invocation on the existing entity object. This occurs because there is no suitable instance in the ready state to service the client call or the EJB timeout method. When an entity bean instance is in the ready state, the instance is associated with the specific entity object identity. While the instance is in the ready state, the container can synchronize the state of the instances with the state of entity in the underlying data source whenever it determines the need to in the process invoking the EJB load, EJB store methods, method 0 or more times. The business method can be invoked on the instance 0 or more times. Or EJB timeout method can be invoked on the instance 0 more times. Invocation to the EJB load and EJB store methods can be arbitrarily mixed with the invocations of business methods and EJB timeout methods invocations. The EJB select method can be called by a business method, or EJB load, or EJB store method, or EJB timeout method while the instance is in the ready state. The container can choose to passivate an entity bean instance within the transaction. To passivate an instance, the container first invokes the EJB store method to allow the instance to prepare itself for the synchronization of the database state with the instance's state, and then the container invokes the EJB passivate method to return the instance to the pooled state. Eventually, the container will transition to the instance to the pool state. There are three possible transitions from the ready to the pooled state. Through EJB passivate method, through EJB removed method, and because of the transaction rollback for EJB create, EJB post create, or EJB remove. It's not shown in the life cycle of the entity bean instance here. The container invokes the EJB passivate method when the container wants to disassociate the instance from the entity object identity without removing the object. The container invokes the EJB remove method when the container is removing the entity object. That is, when the client invoke remove method on the entity object's component interface, or remove methods on the entity bean's home interface. If EJB create, EJB post create, or EJB remove is called, and the transaction rollback, the container will transition the bean instance to the pool state here. When the instance is put back to the pool, it is no longer associated with any entity object identity. The container can assign the instance to any entity object within the same entity bean home. The container can remove the instance in the pool by calling unset entity context method on the instance. Notes the entity context interface passed by the container to the instance in the set entity context method is an interface, not a class that contains specific static information. For example, the result of the entity context.get primary key method might be different each time an instance moved from the pooled state to ready state. And the result of the get caller principal and is caller in role method may be different from each business method. Step 2, a runtime exception thrown from any method of an entity bean class, including business methods and callback invoked by the container, results in the transaction to the does not exist state. The container must not invoke any method on the instance after runtime exception has been caught. From the caller's perspective, the corresponding entity object continues to exist. The client can continue accessing the entity object through its component interface because the container can use the different entity bean or instance to delegate client's requests. 3. The container is not required to maintain a pool of instances in the pool state. The pooling approach is an example of a possible implementation, but it is not required implementation. Whether the container uses a pool or not has no bearing on the entity bean's coding style. Here you can see does not exist interact with pooled does not exist and here you can see instance throws a system exception from any method is connected to does not exist here. Does not exist is connected to pooled through via new instance and set entity context easy to pool is connected to itself through via home EJB home method dogs, and pool is connected to itself via EJB find method dogs, EJB select method dogs. Here pooled interacts with ready. Pooled is connected to ready via EJB create method dogs and EJB post create method dogs. Pooled is connected to EJB via EJB activate. Here ready is connected to itself via EJB load, and ready is connected to itself via business method. Ready is connected to itself via EJB timeout tags. Ready is connected to itself via EJB select, and ready is connected to itself via EJB store, and ready is connected to pooled via EJB passivate method here, and ready is connected to pool via here EJB remove method. And pooled is connected to does not exist via step 1 here unset entity context method. Here you can see multiple clients access the same entity object using multiple instances. When writing the entity bean business methods, bean provider does not have to worry about concurrent access from the multiple transaction. The bean provider may assume that the container will ensure appropriate synchronization for entity objects that are accessed concurrently from multiple transactions. The container typically uses one of the following implementation to implementation strategies to achieve proper synchronization. These strategies are illustrative, not prescriptive. So we are here considering one implementation. The container activates multiple instances of the entity bean, one for each transaction in which the entity object is being accessed. The transaction synchronization is performed by the underlying database during the accessor method calls performed by the business methods. The EJB timeout method and EJB load, EJB create method, EJB store and EJB remove methods. The commit time options B and C in commit options applied to this type of container. So commit options A is commit option B is container caches a ready instance between the transaction. C is container does not cache a ready instance between transactions. With this strategy, the type of lock required by EJB load and EJB get accessor method is if the lazy loading cache management strategy is used, leads to trade-off. If the EJB load or the accessor method acquires exclusive lock on the instances stays in the database, the throughput of the read-only transaction could be impacted. If the EJB load or the accessor method acquires a shared lock and the instance is updated, then either EJB store or the set accessor method will need to promote the lock to an exclusive lock, which may cause a deadlock if it happens concurrently under multiple transactions. So if the container uses an optimistic cache concurrency control strategy, the container will need to validate the state of the cache against the database at the transaction commit, which may result in a rollback of the transaction. Here you can see client 1 and client 2 are connected to entity object account 100. Here the client 1 is connected to entity object account 100 via TX1. Client 2 is connected to entity object account 100 via TX2. Entity object account 100 connected to the container. So here you can see the enterprise bean instances. Entity object account 100 is connected to the entity object account 100 in TX1 here, and account 100 TX1 is connected to the account 100 to the database. The account 100 is inside the database, and here entity object account 100 is connected to the account 100 in TX2 here. Account 100 in TX2 is connected to the database and account 100 is in the database here. So enterprise bean instances are in the container here. Here you can see multiple clients can access the same entity object using single instance. It is expected that the containers will provide deployment time configuration options that will allow control to be exercised over the logical transaction isolation level that their caching strategies provide. The container acquires exclusive access to the entity object's state in the database. The container activates the single instance and serializes the access from multiple transactions to this instance. The commit option A in the commit options apply to this container. Commit option A, the container caches a ready instance between transactions. Here you can see client 1 is connected to entity object account 100 via TX1. Client 2 is connected to entity object account 100 via TX2. Here entity object account 100 interacts with container, and entity object account 100 is connected to account 100 in tx1 here, and enterprise bean instance assigns the container, and here the container blocks client 2 until client 1 finishes, and entity account 100 in tx1 is connected to database, and account 100 is in the database. Here you can see several entity beans with abstract persistent schemas defined in the same EJB-jar file. The following convention refers to the names used for the entity beans in the subsequent these examples. An entity bean as a whole is designated by name EJB, name, then and its entity bean class and abstract schema type are designated by the name. Following convention is used to name the local interface of the entity of an entity bean. This example assumes that the bean provider provides several entity beans: order EJB, product EJB, line item EJB, shipping address EJB, and billing address EJB. The abstract schema types for these entity beans are order, product, line item, shipping address, and billing address, respectively. These beans are logically in the same EJB-jar file as shown here. Only two of the entity beans, order EJB and product EJB, have remote interfaces and remote home interfaces. The entity beans shipping address and billing address each have one-to-many relationships with order. There is also one-to-many relationship between order and line item. The entity bean line item is related to product in a many-to-one relationship. Entity beans query language QL allows the bean provider to specify finder queries for order EJB by navigating over the CMR fields and CMP fields defined by order and line item. A finder method query to find all orders with pending line items might be written as follows here. This query navigates over the CMR field line items of the abstract schema type order to find line items, and uses the CMP field ships of the line item to select those orders that have at least one line item that has not yet shipped. Note that this query does not select orders that have no line items. Although predefined reserved identifiers such as distinct, object, from, as, in, where, and false appear in the uppercase in this example, predefined several identifiers are case insensitive. Select clause in this example designates the return type of this query to be the type of order. If this query is defined for a finder method on the entity bean's remote home interface, the finder method will returns objects of the entity bean's remote interface type corresponding to the abstract schema type instances selected by the query. If the same query is defined For the finder method on the entity bean's local home interface, the finder method will return the objects of the entity bean's local interface type corresponding to the same abstract schema type instances. Finder methods must always returns EJB objects or EJB local object of the bean type for which the query method is defined. Because the same deployment descriptor defines the abstract persistence schemas of the related entity beans, the beans provider can also specify the query for order EJB that utilizes the abstract schema of type of the product EJB. Hence, the comp field and CMR field of both abstract schema types order and product. For example, if the abstract schema type product has CMP dash field named product underscore type, a finder query for the order EJB can be specified using this CMP field. Such a finder query might be find all orders for products with product type office supplies. The enterprise beans QL query string for this might be as follows. Because order is related to the product by means of the relationships between order and line item and between line item and product, the navigation using the CMR fields line items and product is needed to express the query. This query is specified using the abstract schema name for order EJB, schema name for the order EJB, namely order, which designates the abstract schema type over which the query ranges. The basis for the navigation is provided by the CMR fields line items and product of the abstract schema types order and line item respectively. Here you can see a client view of underlying data sources accessed through entity bean. An entity bean implements an object view of an entity stored in the underlying database or an entity implemented by existing enterprise application, for example. A mainframe program or by an ERP application. The data access protocol for transferring the state of entity between the entity bean instances and the underlying database is referred to as object persistence. The entity bean component protocol for bean manage persistent allow entity bean provider to implement the entity bean's persistent directly in the entity bean class or in the one or more helper class process provided with the entity bean class. This here. And here you can see entity bean is an object view of the record in the database. Client is connected to the account entity bean. Account entity bean is in the container and account entity bean is connected to database and account 100 is in the database. Entity bean here, entity bean is an object view of the existing application. Client is connected to the account entity bean. Account entity bean is in the container. Account entity bean is connected to the existing application. Existing application is connected to the database. Account 100 is in the database. Of a simple stateless EJB. This is under EJB version 3.0. In this code, main points to note about on this code, use standard import statement to import metadata annotations you use in the bean file. Annotations that apply only to EJB 3.0 are in Java x.egb package. Annotation that can be used by other platform Enterprise Edition Java EE version 5 compilers are in more generic packages such as Java Interceptor or Java annotations. The service bean file is a plain Java file that implement the service business interface. It is not required to implement any EJB specific interface. This means that the bean file does not need to implement the lifecycle methods such as EJB create and EJB passivate that were required in the 2.x programming model. The class level at stateless metadata annotation specifies that the EJB is of type stateless session. The class level at transaction attribute never annotation specified that the EJB never runs inside of a transaction. The class level annotation exclude default interceptors. Annotation is specified that the default interceptors, if any, are defined in the EJB-jar.xml deployment descriptor file should never be invoked for any method invocation of this particular EJB. Here you can see a example of a simple stateful EJB as an example 2. This is in the version EJB version 3.0. Here use standard imports statement to import the metadata annotations you use in the bean file. Annotations that apply to EJB 3.0 are in the JavaX EJB package. Annotation that can be used by other Java platform Enterprise Edition Java EE version 5 compilers are in the more generic packages such as JavaX Interceptor or JavaX Annotation. The account bean file is a plain Java file that implements the account business interface. It is not required to implement any EJB specific interface. This means that the bean file does not need to implement the lifecycle methods such as EJB create and EJB passivate that were required in the 2.x programming model. The class level at stateful metadata annotation is specified that the EJB is of type stateful session. The class level at transaction attribute never annotation specified that EJB never runs inside of a transaction. The class level at remote annotation is specified the name of the remote interface of the EJB. In this case, it is the same as the business interface account. The class level at interceptors example dot audit interceptor dot class annotation is specified the interceptor class that is associated with the bean file. This class typically include the business method interceptor method as well as lifecycle callback interceptor methods. The field level at EJB annotation specified the annotated variable service is injected with the dependent service bean statal session bean context. The data type of injected field service is the business interface of service of the service bean. EJB. The following code in the say hello from account bean method shows how to invoke the say hello from service bean method of the dependent service bean. Service.say hello from service bean. The method level at exclude class interceptors annotation is specified that the at round invoke method specified in the associated interceptor class audit interceptor should not be invoked for the say hello say hello from account bean method. The method level at pre-destroy annotation is specified that the EJB container should invoke the pre-destroy method before the container destroyed an instance of the account bean. This shows how you can specify interceptor methods for both business methods and lifecycle callbacks in the bean file itself in adding to using an associated interceptor class. As an example 3, we can consider this. Implement the entity bean class. Here in this we can see the code segment here. Here in the full code target methods for the method that are declared in the home interface, which include the EJB create and EJB post create methods with parameters matching the associated create method defined in the home interface, and finder methods other than EJB find by primary key and EJB find all that are defined in the home interface, and the container generates EJB find by primary key and EJB find all methods implementation, although you must still provide an empty method for each of these. Any home interface business method which are dependent with EJB home and in the bean implementation, for example calc salary method, it is implemented in the EJB home calc salary method. The business logic methods that are declared in the component interfaces, the methods that are inherited from javax.egb.entitybean interface. So this is a segment of the class here. As an example we can consider message driven bean class. For the code for the simple message bean class illustrate that the requirements of message driven bean class. It must be annotated with message driven annotation if it does not use a deployment descriptor. Class must be defined as public. The class cannot be defined as abstract or final. It must contain a public constructor with no argument. It must not define finalized methods. It is recommended but not required that a message-driven bean class implement the message listener interface for the message type it supports. A bean that supports the JMS API implements javax.jms.message-listener interface. Unlike session beans and entities, message-driven beans do not have the remote interface or local interfaces that define client access. Client components do not locate message-driven beans and invoke methods on them. Although message-driven beans do not have business methods, they may contain helper methods that are invoked internally by onMessage method. For the Glassfish server, the @message driven beans message driven annotation typically contains a mapped name element that specified the JNDI name of the destination from which the bean will be consumed messages. For complex message driven beans, there can also be an activation config element name containing activation config property annotation used by the bean. A message-driven bean can also inject a message-driven context resource. Commonly, you use this resource to call the set rollback only method to handle exception for the bean that uses container managed transactions. As an example 5, we can consider this. To create an EJB, you must perform these steps. Step 1, create a remote interface for the bean. The remote interface declares the methods that a client can invoke. It must extend javax.egb.egb object. Step 2, create a home interface for the bean. The home interface must extend javax.egb.egb home. In addition, it defines the create method for your bean. Implement the bean. This includes following: the implementation for the methods declared in your remote interface, the methods defined in either javax.egb.sessionbean or javax.egb.entitybean interfaces. For the differences between these type of beans, then the EJB create method with parameters matching those of the create method defined of the home interface. Step 4, create the bean deployment descriptor. The deployment descriptor specified properties for the bean. Step 5, create an EJB-jar file containing the bean, the remote home interfaces, and the deployment descriptor. The EJB-jar file must define all beans within your application. So this is under Oracle 9.9. As an example 6, we can consider EJB application configuration. This is done under jboss.xml file in jboss application server. In the EJB application, you need to modify jboss.xml descriptor file for each stateful session bean and add the clustered tag. In the bean configuration, only the clustered tag is mandatory to indicate that the bean works in a cluster. The cluster config element is optional, and its default attribute values are indicated in the sample configuration here. The session state manager GNDI name tag is used to give the JNDI name of the HA session state service to be used by this bean. The description of the remaining tags is identical to one for stateless session bean. Actions on the clustered stateful session bean's home interface are by default load balanced. Round robin anymore and will stay sticky to the first node in the list. Now we are considering package Jakarta.EJB contains the enterprise bean classes and interfaces that define the contracts between the enterprise bean and its clients and between enterprise bean and the enterprise bean container. Now we are considering enterprise bean object types in overview. Message driven a typical message driven object has following characteristics: executes upon receipt of a single client message, is asynchronously invoked, can be transaction aware, may update shared data in an underlying database, does not represent directly shared data in the database, although it may access and update such data, is relatively short-lived, is stateless, is removed when the enterprise beans container crashes. The container has to re-establish a new message-driven object to continue computation. Typical enterprise beans container provide a scalable runtime environment to execute a large number of message-driven objects concurrently. Now we are considering overview in message-driven bean component contract. A message-driven bean is an asynchronous message consumer. A message-driven bean is invoked by the container as a result of the arrival of a message at destination or endpoint that is serviced by the message-driven bean. Message-driven bean instance is an instance of a message-driven class. A message-driven bean is defined for a single messaging type in accordance with the message listener interface it employs. To a client, a message-driven bean is a message consumer that implements some business logic running on the server. Client accesses a message-driven bean by sending messages to the destination or endpoint for which the message-driven bean class is the message listener. Message-driven beans are asynchronous. They have no client visible identity. Message-driven bean instances have no conversational state. This means that all beans instances are equivalent when they are not involved in servicing a client message. Message-driven bean instance is created by the container to handle the processing of messages for which the message-driven bean is consumer. Its lifetime is controlled by the container. Message-driven bean instance has no state for a specific client. However, the instance variable of the message-driven bean instance can contain state across the handling of the client messages. Example of such state include an open database connection and a reference to an enterprise bean. Now we are considering goals. The goal of the message-driven bean model is to make developing an enterprise bean that is asynchronously invoked to handle the processing of incoming messages as simple as developing the same functionality in any other message listener. The further goal of the message-driven bean model is to allow the concurrent processing of stream messages by means of container providing pooling of the message-driven bean instances. Now we are considering client view of a message-driven bean. For example, a reference to the queue for a Jakarta message-driven bean might be injected as follows. Alternatively, the queue for the stock info Jakarta message-driven bean might be located using the following code segment. Reminder, now we are considering Jakarta message-driven bean, considering message selectors in Jakarta message-driven beans in protocol between a message-driven bean instance and its container. Annotation type message-driven, a component defining an annotation for message-driven bean. This is in the package jakarta.ejp. Bean provider may declare the Jakarta Jakarta message selector to be used determining which messages a Jakarta message-driven bean to receive. If the bean provider wishes to restrict the messages that Jakarta message-driven bean received, the bean provider can specify the value of the message selector by using activation config element in message-driven annotation, or by using activation config property deployment descriptor element. The property name is used to specify message selector is message selector. For example, here and here. The application assembler may further restrict but not replace the value of the message selector property of the Jakarta message-driven bean. Now here we are considering operations allowed in methods of a message-driven bean class in message-driven bean state diagram. Operations allowed in the methods of the message-driven bean defines the methods of the message-driven bean class in which the message-driven bean instances can access the methods of the jakarta.ejb.message-driven context interface, the jakarta.:comp/n environment name context, resource managers, timer service and timer methods, and the entity manager and entity manager factory methods and other enterprise beans. The interface message-driven context The message-driven context interface provides the access to the runtime message-driven context that the container provides for a message-driven bean instance. The container passes the message-driven context interface to an instance after the instance has been created. The message-driven context remains associated with the instance for the lifetime of the instance. This is in the package jakarta.ejb. If the message-driven bean instance attempt to invoke a method of message-driven context interface and the access is not allowed, the operation allowed in the methods of the message-driven bean, the container must throw and log the java.lang.illegal exception. If the message-driven bean instance attempt to invoke the method in the time service or timer interface, and the access is not allowed in operations allowed in the methods of the message-driven bean, the container must throw the java.lang.illegal exception. If the bean instance attempt to access a resource manager, an enterprise bean, or an entity manager or entity manager factory, and the access is not allowed, the operation allowed in the method of the message-driven bean, the behavior is undefined by the enterprise bean specification. Now we are considering the message-driven bean class in the responsibilities of bean provider. The following are the requirements for message-driven bean class. The class must implement directly or indirectly the message listener interface required by the messaging type that it supports all the methods of the message listener interface. In the case of Jakarta messaging, this is the jakarta.jms.message listener interface. The class must be defined as public, must not be final, and must not be abstract. The class must be a top-level class. The class must have a public constructor that takes no argument. The container uses this constructor to create instances of the message-driven bean class. The class must not define the finalized method. Optionally, the class may implement directly or indirectly the jakarta.ejb.message-driven bean interface. The class may implement directly or indirectly the jakarta.ejb.timed object interface. The class may implement the EJB create method. The class may have additional constructor annotated with the inject annotation. Message-driven bean class may have a superclass or super interfaces. If the message-driven bean has a superclass, the message-driven listener methods, the lifecycle callback interceptor method and timeout callback methods, the EJB create method and methods of message-driven bean interface may define in the message-driven bean class or in any of its superclasses. The message-driven bean class is allowed to implement other methods, for example, helper methods invoked internally by the message-driven message listener method in addition to the methods required by the enterprise bean specification. Now we are considering generation of implementation classes in responsibilities of the container provider. The deployment tools provided by the container are responsible for generation of additional classes when the message-driven bean is deployed. The tools obtain the information that they need for generation of additional classes by introspecting the classes and interfaces provided by the enterprise bean provider and by examining the message-driven bean's deployment descriptor. The deployment tool may generate a class that mixes some container-specific code with the message-driven bean class. This code may, or for example, help the container to manage a bean instances at runtime. Subclassing, delegation, and code generation can be used by the tools. Now we are considering container managed transaction demarcation for message-driven beans in container providers' responsibilities in support for transactions. For these enterprise beans, the container must demarcate transaction as specified by the annotations on the bean class or in the deployment descriptor. The container is responsible for providing transaction demarcation for the message-driven beans that the bean provider declared as with container managed transaction demarcation. For these enterprise beans, the container must demarcate transaction as specified by the annotations on the bean class or in the deployment descriptor. Now we are considering not supported in container managed transaction demarcation for message listener methods. The container invokes the message-driven bean message listener method whose transaction attribute is set to not supported with an unspecified transaction context. If the message listener method invokes the other enterprise beans, the container passes no transaction context with the invocation. Now we are considering system exceptions in bean method runs in the context of the transaction that container started immediately before dispatching the method. This case happens with required attributes in exceptions from message driven bean message listener method in container provider responsibilities in exception handling. Here you can see the container action. The class EJB exception. The EJB exception is thrown to report that the invoked business method or callback method could not be completed because of an unexpected error. For example, the instance failed to open a database connection. This is in the package jakarta.ejb. Log on the exception or error. Log on here the log the exception or error means that the container logs the exception or error so that the system administrator is alerted of the problem. Rollback the container started transaction. Discard instance. Discard instance means that the container must not invoke any methods in the instance. Throw EJB exception, the exception that wraps the original exception to resource adapter. Now we are considering message destination reference programming interface in interfaces in bean providers responsibilities in message destination references in enterprise bean environment. The following example illustrates how an enterprise bean uses a message destination reference to locate Jakarta messaging destinations. The bean provider uses message destination references to locate message destination as follows. Assign an entity in the enterprise beans environment to reference. Entity bean specification recommends but does not require that all message destination references be organized in the appropriate subcontext of the beans environment for messaging resource type. For example, in the Java :n/jms JNDI context for Jakarta messaging destinations. Note that the message destination references declared via annotations will not by default appear in the subcontext. Look up the destination in the enterprise beans environment using EJB context lookup method or JNDI APIs. The following example illustrate how an enterprise bean uses message-driven destination references to locate the Jakarta messaging destination. In the example, the bean provider of the stock service bean, enterprise bean has assigned an environment entry JMS/stock queue as the message destination reference name to refer the Jakarta messaging queue. If the JNDI API were used directly, the example would be as follows. Here you can see Java :conf/anv/jms. Declaration of the message destination references in the deployment descriptor. Although the message destination reference is an entry in the enterprise beans environment, the bean provider must not use the environment env entry element to declare it. Instead, the bean provider should declare all references to the message destination using either the resource annotation in the bean code or in the message destination ref element in the deployment descriptor. This allows the EJB jar consumer to discover all the message destination references used by the enterprise bean. Deployment descriptor entries may also be used to specify injection of a message-driven reference into the bean. Each message destination ref elements describe the requirement that referencing enterprise bean has for the reference destination. The message destination ref element contains optional description, message destination type, and message destination usage elements, and the mandatory message destination ref name element. The message destination ref name element specifies the message destination reference name. Its value is the environment entry name used in the enterprise bean code. The name of the message destination reference is relative to the Java :compt/env context. For example, the name should be JMS /stock queue rather than Java :comp/env/JMS /stock queue. The message destination type element specifies the specified type of the reference destination. For example, in this case of a Jakarta messaging destination, its value might be jakarta.jms.queue. The message destination type element is optional if an injection target is specified the message destination reference. In this case, message destination type default to the type of the injection target. The message destination usage element specifies whether the message are consumed from the message destination produced for the destination or both. If the message destination usage element is not specified, messages are consumed to be both consumed and produced. The following example illustrates the declaration of message destination references in the deployment description. Look up the Jakarta messaging stock queue in the environment. Convert the result to the proper type. Obtain the default initial JNDI context. Look up the Jakarta messaging queue in the environment. Convert the result to the proper type. Now we are considering application assembler's responsibilities. The following example illustrates the use of message destination linking in the deployment descriptor. By means of linking the message consumers and producers to one or more common logical destinations specified in the deployment descriptor, the application assembler can specify flow of messages within an application. The application assembler uses message destination element the message destination link element of the message destination ref element and the message destination link element of the message driven element to link message destination references to the common logical destination. The application assembly specifies the link between message consumers and producers as follows. The application assembly uses message destination element to specify logical message destination within an application. The message destination element defines the message destination name which is used for the purpose of linking. The application assembly uses message destination link element of the message destination ref element of the enterprise bean that produces the link, produces the message to link it to the target destination. The value of the message destination link element is the name of the target destination as defined in the message destination name. Of the message destination element. The message destination element can be any module in the same Jakarta E application as referencing component. The application assembly uses message destination usage element. Of the message destination ref element to indicate that referencing enterprise beans produces the messages to the reference destination. If the consumer of messages from the common destination is message driven, the application assembly uses message destination link of the element message driven element to reference logical destination. If the application assembler links the message driven beans to its source destination, he or she should use the message driven type element of the message driven element to specify expected destination type. If the enterprise bean is otherwise a message consumer, the application assembly uses message destination link of the message destination ref element of the enterprise bean that consume messages to link the common destination. In the latter case, the application assembly uses the message destination usage element of the message destination ref element to indicate that the enterprise bean consumes message from the reference destination. To avoid the need to rename message destination to have unique names within the entire Jakarta E application, the application assembler may use the following syntax in the message destination link element referencing application component. The application assembly specifies the path of the EJB jar file containing the reference message destination, appends the message destination name of the target destination. Separated by the path name by hash. The path name is relative to the referencing application component jar file. In this manner, multiple destination with the same message destination name may be uniquely identified. The linking message destination, the application assembler must ensure that the consumers and producers are for the destination require message destination of the same or compatible type as determined by the messaging system. The following example illustrates the use of message destination linking of the deployment descriptor. The application assembler uses message destination link element to indicate that the message destination reference employee employee reimbursement declared in the employee service. Enterprise bean is linked to the expense processing Sorry, here you can here also see the application assembly uses message destination link element to indicate the message driven destination reference employee reimbursement declared in the employee service enterprise being linked to expense processing. Message driven being by means of the common destination expose processing queue. The following example here illustrates using message destination link element to indicate that an enterprise being reference to the expose processing queue that is in the same Jakarta IE application with but in a different EJB jar file. Now we are considering deployer's responsibility. The deployer is responsible for following. The deployer must ensure that all declared message destination references are bound to destination object that exists in the operational environment. The deployer may use, for example, the JNDI linkref mechanism to create symbolic link to the actual JNDI name of the target object. The deployer must ensure that the target object is type compatible with the type declared for the message destination reference. The deployer must observe the message destination link specified by the application assembler. Now we are considering container provider's responsibility. The deployment tools provided by the container provider must be able to process information supplied in the message destination ref and message destination link elements in the deployment descriptor. The container provider must provide the deployment tools that allow the deployer to perform tasks described. The deployment tools provided by the container provider must be able to process information supplied in the message destination ref and message destination link element in the deployment descriptor. The tools must be able to inform the deployer of the message flow between consumers and producers sharing common message destination. The tools must also be able to inform the deployer of any unresolved message destination references and allow him or her to resolve message destination reference by binding it to a specified compatible target object in the environment. Now we are considering entity objects optional in enterprise bean object types in overview. A typical entity object has the following characteristics. It's a part of a domain model providing an object view of the data in the database. Can be long-lived, lives as long as the data in the database. An entity and its primary key survive the crash of the enterprise beans container. If the state of the entity bean was being updated by the transaction at the time of the container crash, the entity state is restored and to the state of the last committed transaction when the entity is next retrieved. Now we are considering entity bean removal in bean provider's view of the timer service in timer service. If an entity bean is removed, the container must remove the timers for that bean. Now we are considering locating an entity bean's home interface in enterprise bean's container in client view of the entity bean. If dependency injection is used, the home interface could be obtained as follows. Annotation type EJB indicates the dependency on the local and no interface or remote view of an enterprise bean. This is in the package Jakarta.ejb. The client obtain an entity bean's home interface through dependency injection or locates an entity bean home interface using JNDI. The client's JNDI name space may be configured to include the home interface of the enterprise beans deployed in multiple enterprise beans containers located on multiple machines on the network. The actual location of the enterprise beans container is in general transparent to the client. For example, the local home interface for account entity bean can be located using following code segment here. If dependency injection were used, the home interface could be obtained as follows. Now we are considering entity bean provider's view of container managed persistence in enterprise bean 2.1 entity beans component contract for container managed persistence. And here are remove protocols and remove methods. Once the shipping address here object used by order has been removed, the billing address accessor method will also return null. Here the void EJB remove method, a container invokes this method before it removes the enterprise bean object that is currently associated with the instance. This is in the interface entity bean and package Jakarta.ejb. When the remove method is invoked in an entity object, the container must invoke the entity bean's provider's EJB remove method as remove method. After bean's provider's EJB remove method returns and the prior to return into the client, the container must remove the entity object from the all relationships in which participate and then remove the persistent representation. Once an entity has been removed from relationship, the accessor method for any relationship to the entity will reflect this removal. The accessor method for one-to-one or many-to-one relationship to entity will return null. Accessor method for many-to-many relationship of the entity will return calculation from which entity object has been removed. The container must detect any subsequent attempt to invoke an accessor method on the removed entity object and throw a java.rmi.no such object exception in the client is a remote or remote client, or the jakarta.ejb.no such object local exception if the client is a local client. The container must detect an attempt to assign a removed no such object or local exception if the client is a local client. The container must detect an attempt to assign removed entity object as the value of the CMR field or another object with an argument to a set accessor method or an argument to a method of java.util-collection API and throw the java.land.illegal argument exception. After removing the entity object from the all relationships and removing its persistent representation, the container must then cascade the removal to all entity beans with which the entity has been previously in container managed relationships for which cascade delete option is specified. More than one relationship may affect the removal of an entity object as in this following example. Once the shipping address object used by the order bean has been removed, the billing address accessor method will also return null. The remove method alone causes only the entity on which it is invoked to be removed. It does not cause deletion to be cascaded to other entity object. In order for the deletion of one entity object to be automatically cascaded to another, the cascade delete mechanism should be used. both relationships now reference to the same entity object. It must be. This is impossible. Now we are considering identification variables in the from clause of and navigational declarations in enterprise bean QL definitions in EJB 2.1 query language for container managed persistent query methods in enterprise beans QL. An identification variables evaluates to a value of the type expression used in a declaring variable. For example, consider this query. An identification variable is a valid identifier declared from clause of an entity beans QL query. Identification variable may be declared using an special operators in and optionally as. All identification variable must be declared in the from clause. Identification variable cannot be declared in other clauses. Identification variable must not be reserved identifier or have the same name as any of the following: abstract schema name or EJB name. Identification variables are case sensitive. An identification variable evaluates to a value of the type of expression used in a declaring variable. For example, consider this query for order EJB. In the from clause declaration in ordered line items L, the identification variable L evaluates to any line item value directly reachable from the order. The CMR field line items is a collection of instances of the abstract schema type line item, and the identification variable L refers to an element of this collection. The type of L is abstract schema type of line item. Identification variable ranges over the abstract schema type of an entity bean. An identification variable designate an instance of an entity bean abstract schema type or an element of a collection of entity bean abstract schema types instances. Identification variables are existentially qualified in an enterprise beans QL query. In identification variable always designates a reference to a single value. It is declared in one of two ways: as a range variable or as a collection member identification variable. A range variable declared using abstract schema name of an entity bean. Collection member identification variable is declared using collection value path expression. And an identification variable declarations are evaluated from left to right in the from clause. A collection member identification variable declaration can use the result of preceding identification variable declaration of the query string. Now we are considering single object finder in finder method return type in overview of bean managed entity persistence in enterprise bean 2.1 entity bean component contract for bean managed persistence. The following code illustrates the definition of a single object finder on the remote home here on the remote home interface. Some finder methods such as EJB find by primary key are designed to return the most at most of the one entity object. Here the class interface entity bean. The entity bean interface is implemented by every entity bean class. The container uses the entity bean methods to notify the entity bean instances of the instances lifecycle event. This in the package jakarta.ejb. For a single object finder, the result or type of a find method defined in the entity beans remote home interface is the entity beans remote interface, and the result type of the find method defined in the entity beans local home interface is the entity beans local interface. The result type of the corresponding EJB find method defined in the entities implementation class is the entity beans primary key type. Following code illustrates the definition of a single object find on a remote home interface. Note that find method defined in the local home interface, however, must not throw an remote exception. Entities home interface. Entities implementation class. Now we are considering EJB create and EJB post create in Enterprise Bean 1.1 entity beans with container managed persistence, in Enterprise Beans 1.1 entity bean component contract for container managed persistence. With bean managed persistence, the entity bean provider is responsible for writing the code that insert the record into the database in the EJB create methods. With bean managed however, with the container managed persistence, container from the database insert after EJB create method completes, the container must ensure that the values of the container managed fields are set to the Java language default, for example 0 for integer, null for pointers, prior invoke in the EJB create method on an instance. Then Enterprise Bean 1.1 entity bean provider's responsibility is to initialize container managed fields in the EJB create method from the input arguments, such as that when the EJB create method returns, the container can extract the container managed fields from the instance and insert them into the database. EJB create methods must be defined to return the primary key class type. The implementation of EJB create method should be coded to return a null. The return value is ignored by the container. Note the above requirement is to allow the creation of an entity bean with bean managed persistent by subclassing an entity bean 1.1 entity bean with a container managed persistent. The Java language rules for overriding methods in subclasses requires the signature of the EJB create methods in the subclass and the superclass to be the same. The container is responsible for creating entity objects representation in the underlying database, extracting the primary fields of the newly created entity bean representation in the database, and for creating the EJB object reference for the newly created entity object. Container must establish the primary key before it invokes EJB post create method. The container may create the representation of the entity in the database immediately after EJB create returns, so it can defer it to a later time. For example, the time after the matching the EJB post create has been called to the end of the transaction. Container then invokes the matching EJB post create method on the instance. The instance can discover the primary key by calling get primary key method on its entity context object. The container must invoke EJB create, perform the database insert operation, and invoke EJB post create in the transaction context determined by the transaction attribute of the matching create method, as described in the Enterprise Beans core contract requirement document subsection container managed transaction demarcation for business methods. The container throws duplicate key exception if the newly created entity object would have the same primary key as one of the existing entity objects within the same home. Now we are considering specification of the attributes for bean methods in bean provider's responsibilities in support for transaction. The transaction attributes are specified for the method defined in the beans component interface and all the direct and indirect super interfaces of the component interface, excluding get EJB home, get EJB local home, get handle, get primary key, and is identical methods. Here the EJB home, get EJB home, get EJB home, obtain the enterprise beans remote home interface. The EJB local home, get EJB local home, obtain the enterprise beans local home interface, and here get handle, obtain a handle for enterprise bean object, and get primary key, obtain the primary key of the enterprise bean object, and is identical. Test if the given enterprise bean object is identical to the invoked enterprise bean object. These are in the interface EJB object and in the package Jakarta.ejb. The bean provider of an enterprise bean with the container managed transaction demarcation may specify transaction attributes for the enterprise bean methods. A transaction attribute is a value associated with the method of an entity bean's home or component interface. Transaction attributes are specified for the method defined in the bean's component interface and all the direct and indirect super interfaces of the component interface, excluding get EJB home, get EJB local home, get handle, get primary key, and is identical. Methods for the method defined in the bean's home interface and all direct and indirect super interfaces of the home interface, excluding get EJB metadata and get home handle methods specific to the remote home interface, and for the timeout callback methods, if any. For entity beans that use container managed persistent, only requires new and mandatory deployment descriptor transaction values should be used for method defined in the beans component interface and all the direct and indirect super interfaces of the component interface, excluding get EJB home, get EJB local home, get handle, get primary key, and is identical method for this method defined in the beans home interface and all direct and indirect super interfaces of the home interface, excluding get EJB metadata and get home handle method specific to the remote home interface. The bean provider and application assemblers must exercise a caution when using requires new transaction attributes with the navigation of the container managed relationships. At higher levels of the isolation are used, navigation of a container managed relationship in a new transaction context may result in deadlock. Containers may optionally support the use of not supported supports and never transaction attributes for the methods entity of the entity beans with the container managed persistence. However, entity beans with container managed persistent that use transaction attributes will not be portable. Container may optionally support the use of not supported support and never transaction attributes for the method entity beans with the consumer managed persistent because the use of these transaction modes may be needed to make the use of container managed persistent with non-transactional data stores. In general, however, the bean provider and application assembler should avoid use of these not supported support and never transaction attributes values for the methods of entity beans with container managed persistent because it may lead to consistent result or to the consistent and or to the partial updating of the persistent state and relationship in the event of concurrent use. Now we are considering application exceptions in exception handling. The Jakarta EJB create exception, Jakarta.ejb.remove exception, and Jakarta.ejb.find exception, and subclasses thereof are application exception used to report the errors to the client from the create, remove, and find methods in the EJB home or EJB local home interfaces of entity bean components. Here the class create exception. The create exception must be included in the throws clauses of all create methods defined in the enterprise beans home or local interface. The class remove exception. The remove exception is thrown at an attempt to remove an enterprise bean object or local enterprise bean object when enterprise bean or the content does not allow the enterprise bean object to be removed. The class find exception. The find exception must be included in the throws clause of every find method of the entity beans home or local home interface. These are in Jakarta, in the package Jakarta.ejb. Now we are considering the timer service interface in the beans provider's view of the timer service in timer service. For an enterprise bean 2.1 entity bean, the result of a get timers is a collection of those timers that are associated with bean's identity. The collection timer get timers returns all active timers associated with this bean. These include both programmatically created timers and the automatically created timers. This is in the interface timer service and in the package jakarta.ejb. Now we are considering bean provider's responsibilities in deployment descriptor. The bean provider is responsible for providing following structural information for entity bean in the deployment descriptor. Re-entry indication, the bean provider must specify whether an entity bean is re-entrant. Entity bean's persistent management. If the enterprise bean is an entity bean, the bean provider must use the persistent type element to declare whether persistent management is performed by the enterprise bean or by the container. Entity bean's primary key class. If the enterprise bean is an entity bean, the bean provider specifies the full qualified name of the entity bean's primary class in the prime key class element. The bean provider must specify the primary key class for an entity bean with bean managed persistent. Entity bean's abstract schema name. If the enterprise bean is an entity bean with container managed persistent and CMP version 2.x, the bean provider must specify the abstract schema name of the entity bean using abstract schema name element. Container managed fields. If the enterprise bean is an entity managed with entity bean with container managed persistent, the bean provider must specify the container managed fields using the CMP field element. Container managed relationship. If the enterprise bean is an entity bean with the container managed persistent and CMP version 2.x, the bean provider must specify the container managed relationship of the entity bean using the relationship element. Find and select queries. If the enterprise bean is an entity bean with container managed persistent and CMP version 2.x, the bean provider must use the query element to specify any enterprise bean QL finder or select query for enterprise bean other than the query the query for the find by primary key method. Now we are considering restrictions in packaging restrictions. Entity beans are not supported with within .var files. These component types must only be packaged in the standalone EJB jar file and an EJB jar file packaged within an .er file, EAR file. Entity beans are not supported with enterprise beans 3.2 Lite API. EJB 5069 error message. The bean's home or local home does not define a no arg create method. Solution: check the home or local home interface for the appropriate create method signature. Running the verifier will help identify the error as well. This is occurred in application server Sun Java Communications Application Server 1.0. Now we are focusing on database files. The physical files where our information resided on disk. Oracle has several types for data files, each for different purpose. Database data files, control files, online redo logs, parameter files, other database related files. Here you can see EJB architecture. Enterprise Java Beans EJB technology define a model for the development and deployment of reusable Java server components called EJB components. EJB component is a non-visual server component with methods that typically provide business logic in the distributed application. Remote client called EJB client can invoke these methods, which typically result the updating of the database. Since ES server uses COBA IIOP protocols, EJB components running on SS server can be called by any other type of ES server client or component, even COBA client using ORB from the other vendors that are compatible with COBA 2.3. Here you can see application server. The application server contains EJB container and can contain other features such as web application container to host web components such as Java server pages and Java servlets. ES server is an application server. You can see EJB container. The EJB container runs EJB components and provide required services such as enforcing application security constraints, managing transactions that involve multiple components and databases, and providing naming service that maps components and the resources to the logical names. The container provides the infrastructure required to run distributed components, allowing client and component developers to focus on programming business logic. And not system level code. EJB client. An EJB client usually provides the user interface logic on the client machine. The EJB client makes calls to remote EJB components on a server and needs to know how to find the EJB server and how to interact with EJB components. EJB components and web components can act as an EJB client by calling methods in another EJB component. Session beans and entity beans. EJB components can be of two types. Most applications include session beans to be invoked directly by clients. Session beans provide the interface between base clients and the server-side implementation of the application. Entity beans provide an abstraction of an object that is stored in a database. Entity beans are not typically invoked directly by base clients. All types of EJBs are implemented by a Java class that contains implementations of remote interface methods. And additional methods for cycle management. And client interfaces client interfaces an EJB client does not communicate directly with EJB component. The container provides proxy objects that implement the component home and remote interfaces. The component's remote interface defines the business methods that can be called by the client. the client calls the home interface methods to create and destroy the component's logical name to the proxy objects that implement the home and remote interfaces. The proxies contain generated code required to invoke component over the network. Beginning in EJB version 2.0, EJB and web components running in the same server can execute EJB components using the component local interface. Using the local interface can improve performance. If an EJB component is not meant to be invoked directly by client application, you can include local interfaces for the component. Here you can see a web client is connected to JSP and servlet. JSP and servlets are inside web application container. Web application container and EJB container inside application server. JSP is connected to local home interface and local interface. Servlet is connected to local home interface and local interface. EJB client is connected to home interface and remote interface. Session bean and entity bean are inside EJB container. Session bean is connected to local home interface and local interface. Local home interface and local interface is inside entity bean, and entity bean is connected to database. Here you can see a database storage structure. Here this diagram shows the logical, physical and recovery related structures of the database and relationships between them. Dotted horizontal lines divide the image into three sections. Top section shows logical structure, middle section shows physical structure, and the bottom section shows recovery related structures in the flash recovery area. In the logical the logical structures are all table spaces. Each table space point to a data file or temp file, which are physical structures. Other physical structures include control files, a server parameter file, and a password file. Here you can see the physical structures include the control file, server parameter file, and password file, and temp file, and data files. Flash recovery area contains following structures: backup of the server parameter file and control file stored in an archival format called a backup set. Another backup set containing a backup of the data files, other online redo files, redo log files, and archived redo files which are copies of redo log files after they are filled. They are filled. Oracle Database Express Edition, Oracle database XE is composed of following storage structures. Logical structure such as table spaces are created and recognized by the database only and are not known to the operating system. Physical structures are those that can be seen and operated on the from the operating system, such as physical files that store data on disk. Recovery related structures such as redo logs and database backups are used to recover the database after an operating system failure, Oracle instance failure, or media disk failure. Recovery related structures are stored in automatically managed disk storage area called flash recovery area. Oracle Database XE completely automates the management of its logical and physical structures and flash recovery area storage. You use Oracle Database XE graphical user interface to monitor these structures, mostly to understand how much storage your application have used so far, how much free storage remains, and whether more space is needed for backups. So here you can see logical structures, physical structures, and flash recovery area. In system table space, syst or AUX table space, undo table space, users table space, and temp table spaces space are in logical structure here. Control file, server parameter file, data files, temp file, and password files are in physical structures. So system table space, systox table space, undo table space, and users table spaces space are connected to data files. Temp table space is connected to temp file. Here you can see backup set, control file, and password parameter file, and backup set data files. Online redo logs and archive redo logs are in data flash recovery area. Control file and server parameter files are connected to backup set. Data files are connected to backup set with data files, and online redo logs are connected to archive redo logs here. As an here you can see updates to simultaneous databases. The enterprise bean architecture makes it possible for all application program to update data in multiple databases in a single transaction. The following figure, a client invokes the enterprise bean X. Bean X updates data using two database connections that the deployer configured to connect with two different databases, A and B. Then X calls another enterprise bean Y. The bean Y updates data in the database C. The enterprise bean server ensures that the updates to database A, B, and C are either all committed or all rollback. The application programmer does not have to do anything to ensure transactional semantics. Behind the scenes, the enterprise bean server enlists the database connections as part of the transaction. When the transaction commits, the enterprise bean server and the database systems perform two-phase commit protocol to ensure atomic updates across all three databases. Here you can see a client is connected to X, and X and Y are in enterprise bean server. X is connected to database A and database B, and X is connected to database Y. X is connected to Y. Y is connected to database C. Here you can see message sent to Jakarta messaging queue and updates to multiple databases. The enterprise beans architecture make it possible for application program to send messages to or receive messages from one or more Jakarta messaging destinations, or to update message data in one or more databases in a single transaction. In the following figure, a client invokes an enterprise bean X. Bean X send messages. They send a message to a Jakarta messaging queue A, and updates data in the database B using connections that the deployer configured to connect with Jakarta messaging service provider and a database. Then X calls another enterprise bean Y. Bean Y updates data in database C. The enterprise bean server ensures that the operations A, B, and C are either all committed or all rollback. The application programmer does not have to do anything to ensure transactional semantics. The enterprise bean X and Y perform the message send and database updates using standard Jakarta messaging and JDBC APIs. Behind the scene, the enterprise bean server enlists the session on the connection to the Jakarta messaging provider and the database connection as part of the transaction. When the transaction commit, the enterprise bean server and the messaging and database systems perform the two-phase commit protocol to ensure atomic updates across all three resources. Here the client is connected to X. X and Y are inside enterprise bean server. X is connected to QA, and X is connected to the queue and database B, and X is connected to Y, and Y is connected to database C. Here you can see the message sent to Jakarta messaging queue serviced by a message-driven bean and updates the multiple databases. In the following figure, the client sends a message to a Jakarta messaging queue A, serviced by the message-driven bean X, and bean X updates the data using two database connections that the deployer configured to connect with two different databases B and C. The enterprise bean server ensures that the dequeuing of the Jakarta messaging message and it's received by beanx and the updates databases B and C are either all committed or rollback. Here the client is connected to the QA and QA is connected to the X. X is in the enterprise bean server. X is connected to database B and database C. Here you can see update to multiple database in same transaction. The enterprise beans architecture allows update of data at multiple sites to be performed in a single transaction. In the following figure, the client invokes at enterprise beanx. Beanx updates the data in database A and then call another enterprise bean Y that is installed in remote enterprise bean server. Bean Y updates data in database B. The enterprise beans architecture makes it possible to perform the updates to database A and B in a single transaction. When X invoke Y two enterprise bean servers cooperate to propagate transaction context from X to Y. This transaction context propagation is transparent to application level code. At transaction commit time, the two enterprise bean servers use a distributed two-phase commit protocol if the capacity exists to ensure atomicity of the database updates. Here you can see client is connected to X is in the enterprise bean server, X is connected to database A, and X is connected to database X is connected to Y is in enterprise bean server, Y is connected to database B. Here you can see updates on multiple databases on multiple servers. A Java client can use Jakarta.transaction.user transaction interface to explicitly demarcate transaction boundaries. The client program obtains the Jakarta.transaction.user transaction interface through dependency injection or lookup in the beans EJB context or in the JNDI namespace. Client program using explicit transaction demarcation may perform via enterprise beans atomic updates across multiple databases residing at multiple enterprise bean servers as illustrated in this figure. The application programmer demarcates the transaction with begin and commit calls if the enterprise beans X and Y are configured to use client transaction. That is, their methods have transaction attributes that either require or support an existing transaction context. The enterprise beans server ensures that the updates to database A and database B are made as part of the client transaction. Here you can see the client begin and commit are inside the client, and client is connected to X is in the enterprise bean server here, and X is connected to database A. Here the client is connected to Y, and Y is in the enterprise bean server, and Y is connected to database B. Here you can see update of multiple databases from non-transactional client. Whenever a client invokes a method on a enterprise beans business interface, on the beans no interface view, on a home or component interface or message listener method, the container interposes on the method invocation. The interposition allows the container to control transaction demarcation declaratively through transaction attributes set by the developer. For example, a session bean method is configured with the required transaction attribute. The container behaves as follows. If the client request is not associated with transaction context, the container automatically initiates a transaction whenever client invokes an enterprise bean method that requires a transaction context. If the client request contains a transaction context, the container includes the enterprise bean method in the client transaction. The following figure illustrates such a scenario. A non-transactional client invokes an enterprise bean X, and the invoke method has required transaction attributes. Because the invocation from the client does not include transaction context, the container starts a new transaction before dispatching the method on X. Bean X work is performed in the context of the transaction. Then X calls in other enterprise beans Y in our example. The work performed by other enterprise beans is also automatically included in the transaction, subject to transaction attributes of the other enterprise bean. The container automatically commit the transaction at time X returns a reply to the client. If a message-driven bean message listener method is configured with the required transaction attribute, the container automatically start a new transaction before delivery of the message and hence before invocation of the method. Jakarta messaging requires that the transaction be started before the dequeuing of the message. The container automatically analyzes the resource manager associated with the arriving message and all the resource managers accessed by the message listener method with transaction. It is illegal to associate Jakarta transactional interceptors with enterprise beans. Here client is connected to X via begin and commit, which is inside enterprise bean server here, and X and Y are inside the enterprise bean server. X is connected to database A and X is connected to Y, and Y is connected to database B. Example here, we configure EJB dash jar.xml file. The environment is Oracle application server log. Oracle application server. The employee example define one-to-one unidirectional relationship in which each employee has only one address. This relationship is unidirectional because you can retrieve the address from employee, but you cannot retrieve the employee from the address. Thus, the employee object has a relationship to its address object. The EJB-jar.xml file has defined the following. Configure each entity element within enterprise-beans section for each of the entity beans involved in a relationship. For example, this includes entity element of employee with EJB name of EMP bean and entity element for the address with the EJB name address bean. Configure the EJB relationship element within relationships section for the one-to-one relationship. For example, it define following. An EJB relationship's role element for the employee being that define the cardinality of as 1 as it's in its multiplicity element. The relationship role source element define the EJB name as EMP bean, which is the same name in the entity. And EJB relationship role element for the address bean that's define its cardinality as 1 in its multiplicity element. The relationship role source element define EJB name as address bean, which is the same name in the entity. Element. Configure a CMR field element in the EMP bean a relationship that points to the address bean. The CMR field element define address as the address bean reference. This element name matches the get and set method names which are named getAddress and setAddress. These methods identify the local interface of the address entity bean as the data type that is returned from the get method and passed on to the method. As an example 2, we can consider QA, PM, WA, EJB data. This data includes information about applications with enterprise Java beans EJB running on WebSphere application server. Each record represents one type of enterprise beans per application module per interval. If there is no bean activity for a particular EJB type, then no record is written. As an error example, we can consider exit status 1. Error in executing the subcommand start database. The start database subcommand start the Java DB server that is available for use with Glassfish server. Java DB is based upon Apache Derby. Use this subcommand only for working with application deployed to the server. This is in the environment Oracle Glassfish server 3.1.2 and 3.1.2.2. So this is the end of my presentation. Thank you very much for watching it.